Hello there, and welcome to Life Beyond Seen, where curiosity slows down, science gets comfortable, and the world becomes just a little easier to think about before sleep. Tonight, we're setting out across a sea that many people know by name, but few people truly know by nature. A sea that sits between islands and countries, oil rigs and fishing boats, ferry routes and wind farms. A sea that can look flat and harmless from a beach on a calm morning, then turn hard, grey and dangerous before the day has finished making up its mind. Tonight, we are talking about the North Sea. Not the biggest sea in the world, not the deepest, not the warmest, friendliest, bluest patch of water you might imagine when someone says the word sea. The North Sea does not usually appear in travel posters with perfect turquoise shallows and palm trees leaning helpfully into the frame. It is more likely to arrive in the mind as a cold grey stretch of water, with wind in its voice, gulls overhead, and somebody somewhere tightening the hood of a raincoat while pretending they are perfectly fine. And yet this sea has shaped history, weather, trade, war, fishing, energy, and the lives of millions of people who live along its edges. It touches the coasts of Britain, Norway, Denmark, Germany, the Netherlands, Belgium, and France. It has carried Vikings, merchants, fishermen, soldiers, migrants, oil workers, sailors, and holiday ferries. It has fed communities, swallowed ships, powered industries, and tested every person who thought they understood what rough water could be. The North Sea is not deadly because it is simply angry all the time. That would almost be easier to understand. A permanently furious sea would at least be honest about its intentions. The North Sea is more dangerous because it is changeable. It is shallow in many places, stormy in many seasons, crowded with traffic, crossed by powerful tides, and filled with hidden banks of sand that do not always stay where people would politely prefer them to stay. Its southern areas are especially shallow, and shallow water can make waves steeper, shorter, and more chaotic than deep ocean swell. Add strong tidal currents, winter gales, fog, cold water, and some of the busiest shipping lanes in the world, and you have a sea that asks to be taken seriously every single day. But before we go further, let me ask you something simple. Where are you listening from tonight? Are you somewhere near the coast, perhaps with the sound of wind outside your window? Are you far inland, tucked away from the sea entirely, listening from a place where water arrives mainly as rain, rivers, or the kettle clicking on in the kitchen? And if you have ever stood beside the North Sea, what did it look like that day? Was it calm and silver, brown and restless? Blue for a brief lucky moment? Or was it doing that very North Sea thing of looking as though it had several complaints and intended to list them all at once? I always like to imagine where these little journeys are being heard. Someone in a quiet room, someone half asleep with a blanket pulled up, someone with headphones on letting the day loosen its grip, someone perhaps living beside the very waters we're about to explore, hearing the word North Sea and thinking, yes, I know that wind, I know that colour, I know that horizon. If you find this kind of calm curiosity soothing, or if this video gives your thoughts somewhere gentle to wander at the end of a long day, I'd be grateful if you gave it a like, subscribed, or left a little note in the comments. It helps this quiet corner reach others who might enjoy drifting through science, history, and the hidden workings of the world without being shouted awake by it. And if you already know the North Sea well, perhaps from fishing, sailing, ferry crossings, coastal walks, or simply years of weather reports that sound like they were written by a dramatic lighthouse keeper, then you may have your own stories to add. Now, I should say, this is still a sleep-friendly journey. We're not here to make the sea feel like a monster under the bed. The North Sea is dangerous, yes, but it is also fascinating, important, and deeply connected to ordinary life. It is a working sea, a lived-with sea, a sea with shipping lanes, fishing grounds, oil platforms, offshore wind farms, research vessels, naval routes, and small harbours where ropes creak and cups of tea go cold, while people check the forecast one more time. It is not a distant wilderness, it is close to home for millions. And that closeness is part of what makes its danger so interesting. The North Sea is not hidden at the edge of the map. It is right there, beside busy countries, under busy skies, carrying busy lives. To understand why it can be so deadly, we need to begin with a small surprise. The North Sea is not especially deep. Many people hear the word sea and imagine a huge dark bowl of water plunging down into mystery. Some seas are like that. The North Sea, for much of its area, is not. It is broad, cold and open, but in many places it is shallow enough that the seabed has a constant say in what happens above it. Especially toward the south, the bottom rises into banks, shoals and shifting sands. The Dogger Bank, for example, is a huge raised area beneath the water, formed from ancient deposits left by Ice Age landscapes and later drowned by rising seas. Today it sits below the surface as part of a complicated seafloor that affects waves, currents, fishing, navigation and weather-driven water movement. That shallowness matters. In deep ocean, waves can roll for long distances with a certain slow power. They may be enormous, but they often have room to stretch themselves out. In shallow water, waves begin to feel the bottom. Their energy gets squeezed upward. Their shape changes. They can become steep and close together, which is exactly the sort of thing that makes life unpleasant for ships, fishing boats, ferries, and anyone who thought they had secured everything properly in the galley. A long ocean swell can lift a vessel with a sort of heavy rhythm. A short, steep sea can smack it, twist it, and throw water over the bow again and again, like a very persistent neighbour knocking with both hands. And then there is the weather. The North Sea sits in a part of the world where air masses often meet, argue, and bring witnesses. Cold air can move down from the Arctic. Moist air can arrive from the Atlantic. Continental air can push in from Europe. Low-pressure systems can sweep across from the west and deepen as they travel. In winter especially, the result can be gales, rough seas, poor visibility, freezing spray, and conditions that change faster than feels reasonable. Modern forecasting is far better than it once was, and today sailors, offshore workers, and coastal communities have tools that earlier generations could hardly have imagined. But better warning does not make the sea harmless. It simply gives people a better chance to respect it in time. If you have ever listened to a shipping forecast, you may know the strange comfort of its language. Viking, Forties, Dogger, Fisher, German Bight, Humber, Thames. The words sound almost like a roll call from another world, calm and formal, even when the conditions they describe are anything but calm. Wind direction, force numbers, sea state, visibility, rain, fog, gale warnings. The phrases are brief, practical, and deeply serious. They exist because out there, on water like the North Sea, small changes matter. A wind freshening from force 6 to force 8 is not just a number getting bigger. It is the difference between difficult and dangerous, between a rough crossing and a crossing that crews will remember. The Met Office still issues shipping forecasts and gale warnings for these named sea areas, because the waters around Britain and the North Sea remain places where weather information is not just interesting but necessary. The North Sea also has tides that move with real force. Water does not simply rise and fall like a bath being filled and drained by a very patient hand. It travels. It runs around coasts, funnels into estuaries, accelerates through narrow passages, and interacts with wind and pressure. Along parts of the British coast and in southern estuaries, tidal ranges can be large enough to reshape the edge of the day for ports, mudflats, beaches, and boats. Strong tidal currents can make navigation difficult, especially where they meet wind blowing the other way. When tide and wind oppose each other, waves can steepen quickly. A patch of sea that looked manageable on paper may begin to stand up in hard little walls, each one arriving before the last has fully finished making its point. Then there are the sandbanks. A rock is at least rude in a straightforward manner. It sits there, it waits. It may be dangerous, but it is usually committed to its location. Sandbanks are more subtle. They can shift. They can rise close to the surface. They can change shape after storms. They can form channels, close channels, and alter the way water moves above them. For older sailors, before modern sonar, satellite navigation, and detailed charts, these banks could be a nightmare. Even now, they remain a serious feature of the sea. A large vessel does not need to be smashed by a dramatic wave to be in trouble. Running aground in the wrong place, at the wrong state of tide, with weather turning and waves building, can become dangerous very quickly. The North Sea has many different dangers layered together, and that is the key. It is rarely one thing alone, it is the combination. Shallow water makes waves steeper. Strong wind builds those waves. Tides move them in awkward directions. Sandbanks disturb them from below. Fog hides what should be visible. Cold water shortens survival time. Crowded shipping lanes increase the need for precision. Offshore structures add complexity. Storm surges can push the sea onto land. And human beings, being human beings, still have to work, travel, fish, repair, steer, drill, build, and rescue in the middle of all of it. The cold is especially important. Cold water is not just uncomfortable, it changes the body fast. It steals heat, strength, coordination, and clear thinking. A person who falls into cold seawater does not have the relaxed amount of time that films sometimes suggest. The first shock can make breathing difficult. Muscles can weaken. Hands stop obeying. Even a strong swimmer can become helpless. This is one of the reasons the North Sea has always demanded practical courage from fishermen, lifeboat crews, sailors, and offshore workers. The danger is not only in the big dramatic storm, it is also in the ordinary accident made worse by cold, distance, darkness, and delay. For centuries, the people living around this sea knew its moods without needing scientific language for all of them. They watched the sky. They knew the smell of weather. They learned which winds brought trouble, which tides exposed safe crossings, and which beaches could vanish under a rushing flood. They built dikes, seawalls, harbours, boats, lighthouses, rescue services, and habits of caution. They gave names to banks, channels, headlands, shoals, and wreck sites. They passed down stories because stories are sometimes how danger survives long enough to become wisdom. Some of those stories are enormous. In 1953, a severe storm surge struck the North Sea coasts of the Netherlands and eastern England. Hurricane-force winds pushed water southward, and the surge arrived with devastating results. Large areas were flooded, sea defences failed, and thousands of lives were lost across affected regions and at sea. In the Netherlands, the disaster became a turning point that led to the Delta Works, one of the most ambitious flood defence projects in the world. In Britain, it helped shape modern flood warning and coastal protection. That event is still remembered because it showed, in the hardest possible way, that the North Sea is not only dangerous to ships. Under the wrong conditions, it can come ashore. That is a different kind of fear from the fear of rough water. A storm at sea threatens those who are out in it. A storm surge threatens people sleeping in houses, livestock in fields, towns behind embankments, roads, farms, and whole coastlines that believed there was still enough barrier between daily life and the water. A surge is not a normal tide. It is water raised and driven by weather, low pressure, and wind, arriving on top of the tide that was already coming. If that happens at the wrong time, with a high spring tide and a coastline shaped in a vulnerable way, the sea can rise to levels that overwhelm defences. It does not need to roar like a film scene to be deadly. Sometimes it just keeps rising. The North Sea's shape helps make this possible. It narrows toward the south, with water pushed down between Britain and continental Europe. In certain storms, wind can drive water into this narrowing space. The water has fewer places to go, so levels rise. Estuaries and low-lying coasts are especially vulnerable. The Netherlands understands this deeply, perhaps more than almost anywhere on Earth. Much of the country's relationship with the sea has been a long negotiation involving engineering, vigilance, memory and respect. The British East Coast has its own long history of floods, eroding cliffs, lost villages and communities that know the sea is not just scenery. It is a neighbour with boundaries that must be watched. And yet, the North Sea is not only a place of disaster, it is also a place of work and life. It has some of the busiest maritime routes on the planet. Ships move through it carrying fuel, food, cars, machinery, chemicals, containers, passengers, and all the quiet ingredients of modern life that most of us never think about until a shelf is empty. Fishing vessels still head out into rough weather because livelihoods are tied to what can be caught. Helicopters carry workers to and from offshore platforms. Maintenance crews service wind turbines far from shore. Rescue teams train for conditions most of us would rather experience only as a very convincing sound effect. This makes the North Sea a strange mix of ordinary and extreme. On land, people may be eating breakfast, checking emails, or wondering whether to put the bins out before the rain starts. A few miles offshore, someone may be dealing with strong crosswinds, heaving decks, freezing spray, poor visibility, and machinery that cannot simply be left for a nicer day. The distance between comfort and danger can be surprisingly small. Sometimes it is only the width of a harbour wall. It is tempting to think that modern technology has solved most of this. We have satellites, radar, GPS, automatic identification systems, digital charts, advanced forecasts, survival suits, helicopters, lifeboats, storm barriers, and vessels far stronger than the wooden ships of the past. All of that matters. It saves lives. It makes the sea more readable. But the North Sea has not become gentle just because we have become clever. Technology reduces risk. It does not remove the water, the weather, the cold, the tide, or the sudden mechanical failure at exactly the wrong moment. The sea is still bigger than the plane. That is why tonight's journey is not really about calling the North Sea dangerous in a simple, dramatic way. It is about understanding the details. The deadliness of this water comes from practical facts, not legend. It comes from geography, from depth, from wind, from current, from human traffic, from history, from coastlines that are low, busy and exposed, from the way a storm can travel across a shallow basin and turn a working sea into a test of judgment. So settle in and let your thoughts move slowly toward that grey horizon. Imagine standing on a cold beach in the early evening. The sand is damp and firm beneath your feet. The air smells of salt weed and distant rain. Far out, a ship shows as a small dark shape against the light. Gulls move above the water with that effortless confidence gulls have, as though they personally invented wind and are still waiting for proper credit. The sea is not wild tonight. Not yet. It lifts, folds, and breaks in low, restless lines. It seems almost modest from here. But beneath that surface, the tide is moving. Farther out, channels deepen and banks rise. Weather systems are forming beyond sight. Boats are checking forecasts. Crews are making decisions. Ports are watching schedules. Somewhere, a buoy is recording wave height. Somewhere else, a lighthouse still stands because people learned long ago that the edge of this sea needs marking. And with that quiet image in mind, we can begin where the danger truly begins. Not with the storms, not with the wrecks, not even with the famous floods, but with the shape of the sea itself. Because the North Sea's first trick is that it looks wide and open, while much of it is surprisingly shallow, and shallow water has a temporal its own. The first thing to understand about the North Sea is that its danger does not begin with thunder, lightning, or waves the height of buildings. It begins with the bottom. That may sound a little unfair to the surface, which usually gets all the attention. When people imagine a deadly sea, they tend to picture dark waves, white spray, ships pitching hard, and a sky that looks like it has made several poor decisions. But the North Sea's temper is not only written above the water, it is built into the shape beneath it. The seabed is not a simple empty floor. It rises, dips, shifts, catches, channels, and interferes. And because so much of the North Sea is shallow, the bottom is always involved in the conversation. The North Sea covers a wide area between Britain, Scandinavia, and mainland Europe. But for a sea with such a serious reputation, it is not especially deep. Its depths commonly range from about 37 to 91 metres, while the southern part can be less than 35 metres deep in many places. Few parts are deeper than 90 metres, though there are deeper areas and trenches toward the north and west. So, in plain terms, the North Sea is broad, busy, cold, and often surprisingly thin from surface to seabed. It is not a deep ocean basin where waves can pass across enormous depths without much interference from below. It is a shallow shelf sea, and that one detail changes nearly everything. A shallow sea behaves differently from a deep one. In deep water, waves can travel with long rolling movement. There is room below them. Their energy moves through the water, and the seabed is often too far down to matter very much. But in shallow water, waves begin to feel the bottom. That phrase sounds almost too casual, as if the wave is putting one cautious foot down before getting out of bed, but it describes something real. As waves move into shallower water, the seafloor slows and reshapes them. Their speed and wavelength decrease, their height can increase, and their fronts can become steeper until they break or turn rough and confused. Now, that does not mean the whole North Sea is one endless beach wave breaking dramatically like something from a surfing film with a very cold cast. But it does mean that the sea's shallowness makes its waves more compact, sharper, and more awkward than many people expect. A deep ocean swell can feel like a slow lift and fall. A shallow, wind-driven North Sea can feel more like being nudged, shoved, slapped, and corrected by water that has read none of the rules of polite behaviour. This is one reason sailors sometimes describe North Sea conditions as short and steep. The waves may not always be the tallest in the world, but they can be close together, irregular, and hard to ride smoothly. For a ship, that matters. A vessel can often manage large, long waves if they are spaced far enough apart and moving in a regular pattern. It rises, falls, and recovers. But short, steep waves come quickly. The bow may climb one wave only to meet the next before the ship has settled. The motion becomes tiring for crews, punishing for machinery, and dangerous for smaller boats. It can make decks wet, visibility worse, steering more difficult, and simple tasks feel as though someone has hidden the floor and replaced it with a stubborn animal. The shallow shape also means that weather can turn water rough in a relatively short time. In a deep ocean, strong wind blowing across a huge distance can build a large swell over time. The North Sea has plenty of wind, but it does not need to behave like the open Atlantic to become dangerous. Its basin is shaped in a way that can produce steep seas when strong winds push across its surface. The waves do not always need a long, elegant journey. They can build in a hard, local, messy way, especially when the wind has enough distance, or fetch, to work with. Wind speed, wind duration, and fetch are the main ingredients in wind-driven wave growth, which means a strong wind over a broad stretch of North Sea water can quickly create conditions that are far more serious than the word shallow might suggest. This is where the North Sea can trick the imagination. Shallow often sounds safe. A shallow pond is not very frightening unless one is a particularly nervous duck. A shallow swimming pool does not usually inspire epic caution, apart from the small sign that says not to dive. But a shallow sea is a different matter. When a large body of water is shallow over a wide area, the seabed affects the movement above it again and again. The energy of the wind has less depth in which to spread itself. The waves become steeper, currents interact more strongly with the bottom, sand and sediment are moved around, channels and banks shape the water, and the whole sea becomes more responsive to changes in weather, tide, and pressure. The North Sea's floor is also irregular. It is not a flat tray. It has broad, shallow areas, deeper channels, banks, and old glacial features left behind from a very different world. During the last ice age, the area we now call the North Sea was not always sea. Much of the southern basin was land at different times, including the now famous drowned landscape often called Doggerland. People and animals once moved across areas that are now underwater. Rivers crossed it. Plains stretched there. Then, as ice melted and sea levels rose, the water returned and covered the land. What had been ground beneath feet became seabed beneath waves. That long history helps explain features such as the Dogger Bank. Dogger Bank is a huge shoal in the North Sea, about 100 kilometres off the northeast coast of England. It is roughly 260 kilometres long and 60 kilometres wide at the 35-metre level, and in places its shallowest parts are only about 15 metres below the sea surface. Britannica describes it as a large moraine, a deposit left at the southern edge of the last glaciation. In less tidy language, it is one of the North Sea's great underwater interruptions, a raised area where the bottom comes up toward the surface and reminds ships and waves that the sea is not as deep as it looks from above. Dogger Bank has been known for centuries as a fishing ground, partly because shallow banks can support rich marine life. Food chains gather around these places, fish feed there, fishermen follow the fish, the sea gives, and then, in its usual complicated fashion, also makes the giving difficult. A productive shallow bank can also be a navigational problem, especially when weather worsens. Water moving over a bank can behave differently from water around it. Waves can steepen as they pass into shallower depths. Currents can accelerate or twist. In rough weather, an area that is valuable in calm conditions can become a place where caution is not optional. The old fishermen of the North Sea knew this not as theory, but as daily fact. They did not need a neat diagram of wave transformation to understand that some patches of water stood up more sharply than others. They learned it in their hands, feet, stomachs, and memories. One bank might be manageable in one wind and miserable in another. A channel might be safe at one state of tide and troublesome at the next. A shoal might be marked on a chart but still demand respect, because the sea above it could change its character with a shift of wind, pressure, or current. There is a type of knowledge that comes from reading instruments, and another that comes from years of being corrected by water. The North Sea has provided many corrections. Sandbanks are especially important in the southern North Sea. Many of them are shallow and shifting, shaped and reworked by tidal currents. That last word, shifting, is doing a lot of work. A mountain is inconvenient, but at least it does not usually wander into a shipping lane overnight. Sand is less committed. It can be moved by currents and storms. Banks can change shape. Channels can alter. A seabed made of sand and sediment is alive in a slow, physical sense, constantly adjusted by water passing over it. For navigation, this has always been a serious issue. The North Sea's southern shallows contain many banks that have long presented hazards to ships, and those hazards become worse when storms reduce visibility or push vessels off their intended track. Before modern electronic navigation, this made the North Sea particularly unforgiving. Sailors used lead lines, charts, landmarks, lighthouses, experience, and a great deal of nerve. Depth was not an abstract number, it was survival information. A vessel that grounded on a sandbank could be battered by waves, damaged by its own weight, or stranded until the tide changed. If the weather was bad, waiting for the tide was not always a gentle activity. A ship stuck where waves were breaking or steepening could be hammered repeatedly. The crew might be close to land and still in grave danger, which is a very North Sea kind of cruelty. Safety might be visible, but not reachable. Even today, with GPS, echo sounders, radar, digital charts, buoyage systems and traffic monitoring, shallow water remains important. Modern tools are excellent, but they do not make a deep channel wider, a bank lower, or a storm more polite. Ships are larger now. Some have deep drafts, meaning they need plenty of water beneath their keels. Navigating a busy, shallow sea is not simply a matter of pointing the bow and hoping the electronics are feeling cheerful. It requires route planning, tide calculations, weather awareness, traffic separation, pilotage, and constant attention. A mistake that might be inconvenient in open, deep water can become serious in a shallow, crowded, fast-changing sea. The word crowded belongs here too, even though this part of the journey is mainly about depth. The North Sea is not a lonely wilderness. It carries major shipping routes connecting some of Europe's busiest ports. It contains fishing grounds, offshore platforms, submarine cables, pipelines, wind farms, military areas, and protected zones. A shallow sea with many users is a complicated sea. Vessels cannot always simply move wherever they like to find easier water. They follow channels, avoid restricted areas, obey traffic lanes, and work around other vessels. In rough weather, the room for error can shrink. The water is not only physically shallow, it is operationally tight. There is also a difference between being near land and being safe. The North Sea is bordered by familiar countries with lights, ports, ferries, harbours, and coastguards. That can make it feel less remote than a distant ocean crossing. But many of its most dangerous conditions happen precisely because it is a shelf sea surrounded by complex coastlines. Water is pushed, funneled, reflected, and squeezed. Tides move around Britain and into the southern basin. Storm winds can pile water toward low-lying coasts. Sandbanks and estuaries complicate flow. A ship may be only a few hours from port, but if the weather closes in, those few hours can become very long indeed. A shallow sea also has a closer relationship with sediment. Waves and currents stir the bottom more easily. Sand, silt, and mud can be lifted into the water. This helps give parts of the southern North Sea their brown or grey appearance, especially near coasts and estuaries. It is not dirty in the simple sense. It is active. The water is carrying material, it is working on the bottom, and the bottom is working back. This matters for visibility underwater, for ecosystems, for dredging, for ports, and for the way the coastline changes over time. The edge of the North Sea is not fixed like a line drawn with a ruler. In many places, it is being negotiated daily by waves, tides, sediment, and human engineering. On the east coast of England, for example, erosion has long been part of the story. Soft cliffs and low-lying areas have been eaten away over generations. Villages have been damaged or lost. Beaches change. Sea defences are built, repaired, questioned, strengthened, or abandoned. Along the Dutch, German, Danish, and Belgian coasts, the relationship with shallow water and low land has required constant management. Dikes, dunes, barriers, sluices, pumping systems, and coastal monitoring are not decorative. They are part of living beside a shallow, energetic sea. The danger is not only offshore, it reaches the land through erosion, flooding, and storm surge. That is another thing shallow water can do. It can make storm surge more dangerous. When low pressure and strong winds push water across a shallow basin, the water has nowhere deep to hide. It can pile up against coasts, especially where the shape of the sea funnels it. The southern North Sea is particularly vulnerable to this because of its narrowing shape and the low-lying coasts around it. When a surge arrives on top of a high tide, the result can be flooding. This is not the main story for this part, but it is impossible to talk about the North Sea's shallow temper without noticing that the same shape that steepens waves also helps the sea rise against the land under the wrong weather conditions. Britannica notes strong tidal currents and the 1953 storm surge as part of the North Sea's danger, and that disaster remains one of the clearest reminders that shallow coastal seas can become deadly far beyond the harbour mouth. There is a practical lesson in all of this, and it is a quiet one. Depth is not just a number on a chart, it is behaviour. 30 metres of water does not simply mean 30 metres of space below a vessel. It means a certain kind of wave response, a certain relationship with wind, a certain kind of current, a certain risk near banks, a certain amount of sediment movement, and a certain vulnerability to storm surge. In the North Sea, the numbers describe a place where the seabed is close enough to influence daily life above the surface. To picture it, imagine a tablecloth with a large sheet of water moving over it. Now imagine there are raised places under the cloth, low places, ridges, channels, and patches that can shift. If the water were very deep, those irregularities might not trouble the surface much. But if the water is shallow, every raised patch matters. The surface reacts. The movement changes. Add wind pushing from one direction and tide pulling from another, and suddenly the simple idea of waves moving across water becomes much more complicated. The North Sea is full of these complications. It is less like a bowl and more like a wide flooded landscape with weather working over the top. This also explains why the North Sea can look deceptively ordinary from shore. A person standing on a beach may see low waves, grey water, a few distant ships and think the sea is calm. And perhaps it is calm that day, but the dangerous character of the North Sea is not always visible in a single glance. It is in the forecast, the tide table, the depth chart, the wind direction, the bank hidden below, the current crossing the route, and the speed at which conditions can change. This surface is only the front page. The real story has many pages, and several of them are damp. For small boats, the shallow nature of the sea is especially relevant. A fishing boat, lifeboat, yacht, or workboat has to deal with motion more directly than a large ship. Short, steep seas can stop progress, throw spray, exhaust crews, and increase the risk of gear breaking or people being injured. A boat that might feel steady in long swell can become uncomfortable and vulnerable in confused shallow water. Anyone who has spent time on a small vessel knows that the height of a wave is not the only thing that matters. Its shape, spacing, direction, and timing are just as important. A modest wave arriving badly can be more troublesome than a larger wave arriving kindly. The North Sea is not always kind with timing. The bottom can also turn currents into local problems. Water moving over uneven depths does not always flow in smooth, predictable lines. Around banks and through channels, currents may strengthen. Where currents meet waves, the sea can become rougher. Where wind opposes tide, waves can stand up sharply. Mariners often pay close attention to wind against tide situations because they can produce steep, uncomfortable seas very quickly. In a shallow basin, this effect can be stronger and more widespread. It is one reason a forecast that sounds manageable in simple wind terms may still require thought. The tide may have other opinions, and the tide is not known for attending meetings. There is an old human habit of ranking danger by size. Bigger must mean worse, deeper must mean more serious, farther away must mean more deadly. The North Sea quietly argues against all of that. It is not the largest sea. It is not the deepest. It is not remote in the way the Southern Ocean is remote, but it is deadly because of the way its features combine. Shallow depth, strong tides, frequent storms, cold water, heavy traffic, banks and shoals, low coasts, sudden changes. None of these alone explains everything. Together they make a sea that has to be understood in layers. This layered danger is why the North Sea has produced such a strong culture of seamanship. People who work there tend to respect details. They notice the direction of the wind. They know the forecast areas. They understand that leaving port is not just about whether the engine starts and the sky looks acceptable. They know that banks, tides, and depth shape the day. Good seamanship is not drama. It is preparation. It is checking, waiting, choosing, turning back, securing gear, plotting routes, and not trusting calm water too much. The North Sea has little patience for pride and even less for guesswork. At the same time, it is worth remembering that the North Sea's shallowness is not only a danger, it is also one reason it has been so productive and useful. Shallow shelf seas often support rich ecosystems. Because sunlight can reach more of the water column, nutrients are mixed, and marine life can thrive in complex habitats. Fishing communities grew because the sea gave food. Modern offshore wind farms are possible partly because shallower waters make turbine foundations more practical than they would be in very deep ocean. Oil and gas development also became central to the region's modern history. So the same shallow shelf that makes the sea rough, busy and hazardous has also made it valuable. The North Sea gives with one hand and makes you read the safety manual with the other. That balance is part of its character. It is not a villain. It is not out to get anyone. It is a physical place with physical rules, and those rules are strict. Shallow water does not care whether a crossing is important. A sandbank does not move aside because a schedule is tight. A steep sea does not soften because someone has dinner plans in Rotterdam. The North Sea's danger comes from indifference, not malice. That may be less dramatic, but it is more true. So when people say the North Sea has a deep temper, they're not talking about depth in meters. They're talking about consequences. A shallow seabed can create deep trouble. It can turn wind into steep waves, tides into hard-running currents, banks into hazards, and storms into coastal floods. It can make a familiar sea behave with a force that surprises anyone who mistakes nearness for safety. Now imagine again that grey water from the shore, but this time with the bottom included in the picture. Out beyond the beach, the seabed slopes and rises. Sandbanks sit beneath the surface, channels carry tide. A ship in the distance follows a route chosen not only for where it wants to go, but for the water it must safely pass through. The waves above are shaped by ground below. Nothing is empty, nothing is simple. The whole sea is a moving system, shallow enough for the bottom to matter and wide enough for weather to gather strength. And once the shape of the sea is understood, the next part becomes easier to see. The North Sea's shallow floor sets the stage, but weather is the actor that keeps changing the scene. A calm morning can become a hard afternoon. A manageable forecast can turn serious when pressure falls, wind builds, and cold air moves across open water. The seabed gives the North Sea its temper, but the sky often decides when that temper shows. The seabed gives the North Sea its restless shape, but the sky decides when that restlessness becomes trouble. A shallow sea can be awkward on an ordinary day. Add fast-changing weather, and it becomes something far more serious. Not always dramatic at first, not always with a dark wall of cloud or a neat warning sign written across the horizon. Sometimes it begins with the wind freshening a little, then a little more. Then the grey surface starts to roughen, small waves sharpen into hard edges, and before long the whole sea seems to have changed its mind. This is one of the North Sea's most dangerous habits. Conditions can shift quickly. A morning that starts with manageable seas can become an afternoon of steep waves, poor visibility and hard wind. The North Sea is known for frequent storms, especially in winter, and its shallow depth, strong tidal currents, and rough weather are all major reasons it has such a dangerous reputation. The phrase, "without warning," needs a little care here. Modern weather forecasting is not helpless. We have satellites, buoys, radar, computer models, coastal stations, shipping forecasts, gale warnings, radio broadcasts and phones that can tell us the wind speed while we're still wondering where we left our other glove. The sea is much better watched than it used to be. But warnings are not the same as control. A forecast can tell you trouble is possible, likely, or coming. It cannot smooth the water for you. It cannot turn a fishing boat around by itself. It cannot stop a crew from needing to work, a ferry from needing to cross, or a small vessel from already being too far from shelter when the weather begins to turn. And for the people on the water, a change that looks predictable on a chart can still feel sudden in the body. 1 hour you're moving through grey but workable water. The next, the deck is wet, the bow is slamming. Loose objects are trying to escape their cupboards, and somebody's cup of tea has become less a beverage and more a small interior weather event. That is the practical meaning of sudden weather at sea. Not that the sky is magic, just that water, wind, tide, and human timing can come together faster than comfort allows. The North Sea sits in a busy atmospheric crossroads. To the west lies the Atlantic, where low-pressure systems often form and travel eastward. To the north, colder Arctic air can move down. To the east and south, continental Europe can send out air that is colder, drier, warmer, or more unstable depending on the season. Above all this, the jet stream can guide weather systems across the region, sometimes quickly, sometimes in repeated waves, as if the atmosphere has found a route it rather likes, and sees no reason to stop using it. The result is changeability. Not every day, of course. The North Sea can be calm. It can lie under a pale sky with low waves and a quiet horizon, looking almost sleepy itself. But its location means it is often exposed to passing fronts, deepening lows, strong pressure gradients, and winds that have enough distance across the water to build rough seas. Wind-generated waves depend mainly on wind strength, wind duration, and fetch, which is the uninterrupted distance over water that the wind blows in one direction. When those factors line up, waves grow. Fetch matters a great deal. A breeze over a pond makes ripples. A strong wind blowing for hours across a broad stretch of sea builds something very different. The North Sea is not as vast as the open Atlantic, but it is wide enough for wind to work. From north to south, from east to west, there are many situations where air can blow across long, open distances of water. If that wind is strong and if it keeps blowing, the surface does not remain polite for long. At first, tiny ripples appear. These make the surface rougher, which lets the wind grip the water more effectively. Then the waves grow. The rougher the surface becomes, the easier it is for the wind to transfer more energy into it. It is a feedback process, a little like trying to tidy a room while a toddler is actively emptying drawers behind you. The more movement there is, the more movement can be added. NOAA explains that wind creates waves through drag on the water surface, and as the surface roughens, the wind can push it more effectively. In the North Sea, those waves do not always have the long rolling character of deep ocean swell. The shallow bottom shortens and steepens them, so the weather does not need to create the biggest waves on Earth to create serious danger. It only needs to create steep, confused, closely spaced waves in a sea already shaped by tides and banks. That's enough, especially for smaller boats, especially in cold water, especially when visibility falls and daylight fades. Winter is when the North Sea's weather often becomes most severe. Colder air, stronger temperature contrasts, and more frequent Atlantic low-pressure systems can all contribute to rougher conditions. Storms sweeping across or near the region can bring gales, high winds, heavy rain, sleet, snow, and sudden drops in visibility. Britannica notes that the North Sea is especially known for harsh winter weather, with frequent storms, gales, high winds, and low temperatures creating dangerous conditions for vessels. There is something particularly unforgiving about winter weather at sea. In summer, a strong wind is still serious, but daylight is longer, temperatures are kinder, and the body has more room for error. In winter, everything tightens. The air bites. Sea spray can feel like thrown gravel. Hands stiffen. Metal becomes colder to touch. Wet clothing steals heat. Darkness comes early and stays late, like an unwelcome guest who's found the spare blanket. If something goes wrong, the margin for recovery is thinner. The North Sea's weather also changes through fronts. A warm front may bring thickening clouds, steady rain, and poor visibility. A cold front can bring a sharper shift, with squalls, sudden gusts, heavy showers, and a wind change. Behind it, colder air may pour over the sea, creating more showers and unstable conditions. To someone on land, this might mean putting up an umbrella and making an unhappy noise at a bus stop. At sea, a front can mean a deck becoming unsafe, a course becoming harder to hold, or waves suddenly striking from a more awkward angle. Wind direction is not just a detail. It decides how the sea builds, where water piles, and how waves meet the tide. A northerly gale can drive cold air down the length of the sea. An easterly wind can hammer parts of the British East Coast. A westerly or southwesterly pattern can bring Atlantic systems across Britain and into the North Sea. Every direction has its own consequences depending on where you are. Mariners think in these terms naturally. A land forecast may say windy. A sea forecast must ask where from, how strong, for how long, over what distance, against which tide, near which banks, with what visibility, and at what time of day. It is a much longer conversation. This is why the shipping forecast has such a particular importance around Britain and nearby waters. The Met Office provides sea area forecasts with wind, weather, visibility, and sea state, including warnings of gales and storms for named areas such as Viking, Forties, Dogger, Fisher, German Bight, Humber, Thames, and others. The names may sound calm when read aloud. Dogger, Fisher, Forties, German Bight. There is something almost bedtime-like about the rhythm of them, which is slightly unfair because what they often describe is not bedtime-like at all. Gale 8, severe gale 9 later, is not a lullaby unless you're a very unusual lighthouse. Still, there is comfort in the precision. The shipping forecast exists because general weather language is not enough for sea users. A person driving to the shops may only need to know whether it will rain. A vessel crossing the North Sea needs wind speed, wind direction, visibility, sea state, and warnings that may affect a precise route. The difference between good and bad information can be the difference between a hard day and a dangerous one. The North Sea does not reward vague optimism. Fog is another weather danger, and it has a special talent for making the familiar strange. The North Sea can produce thick fog and low cloud when moist air moves over colder water or when conditions allow visibility to collapse. Fog does not shove a vessel the way a wave does. It does not scream like wind in rigging. It just removes the world. The horizon disappears, lights blur, distances become uncertain, sounds behave oddly. A ship that was comfortably far away becomes a question. A buoy that should be obvious becomes a small shape arriving late. Even with radar and modern navigation, fog increases workload and risk, especially in crowded waters. There is an old kind of fear in fog. It is not the fear of being attacked by the sea, but of being quietly misplaced inside it. Before radar, fog could be terrifying. Sailors listened for bells, horns, engines, surf, and the calls of crew. Lighthouses and fog signals mattered enormously. A vessel might be near a coast, a bank, or another ship, and not know it until the sound changed. Modern equipment has reduced this danger, but it has not removed it. Machines help people see through fog, but people still have to interpret, decide, and react. And the North Sea, with its traffic, platforms, wind farms, banks, and routes, is not a place where blindness is welcome. Rain and spray add their own complications. Heavy rain can reduce visibility and make radar images cluttered. Spray can cover windows, freeze in cold conditions, and make decks slippery. Strong gusts can arrive in showers, hitting harder than the background wind. Squalls are especially unpleasant because they can feel like the weather briefly losing patience. One moment the wind is strong but steady. The next, it lunges. A vessel heels, gear shifts, the sea surface whitens, and everyone remembers that just a shower can still have a very forceful personality. There is also the matter of air pressure. Low pressure allows sea level to rise slightly, because there is less atmospheric weight pressing down on the water. Strong winds can then push that water toward coasts. When this happens over the North Sea, especially with the right wind direction and timing, it can contribute to storm surge. This becomes most dangerous when surge coincides with high tide. Then the sea does not merely become rough offshore, it climbs higher along the land. The North Sea's storm surge history shows how weather can turn from maritime hazard into coastal disaster. The 1953 North Sea flood remains one of the clearest examples. A severe storm and surge caused catastrophic flooding in the Netherlands and eastern England, killing many people and leading to major changes in flood defence and warning systems. The lesson was not simply that the sea can be rough, it was that weather over a shallow, funnel-shaped sea can push water into places where people live, sleep, farm and build. For those offshore, falling pressure can also be a warning sign of a deepening system. Barometers were once watched with almost personal suspicion. A falling glass could mean worsening weather. Even now, pressure matters, though it is wrapped inside forecast models and digital displays. The old tools and the new tools are part of the same effort, which is to notice the atmosphere before the atmosphere has fully arrived. The trouble is that the North Sea's weather often does several things at once. It does not politely choose one hazard and present it in an orderly fashion. A storm may bring strong winds, heavy rain, poor visibility, steep waves, wind against tide conditions, falling temperatures, and a risk of surge along parts of the coast. That combination matters more than any single number. A wind speed alone does not tell the whole story. A wave height alone does not tell the whole story. The whole story is how the pieces meet. Wind against tide is one of those meetings. When the tidal current runs one way and the wind blows hard the other way, waves can steepen sharply. The water moving beneath the waves changes their shape and behaviour. The sea may become lumpier, harsher, and more confused. This is especially important around headlands, estuaries, banks, and channels, where currents are already stronger or more complicated. A vessel may leave harbour in conditions that seem acceptable, only to find that a certain stretch of tideway is behaving like a staircase built by someone who dislikes boats. The North Sea's strong tides are not separate from its weather danger. They are partners. Weather supplies the energy from above, tides move water from within the basin, the seabed shapes that movement from below. When all three align badly, the sea becomes difficult fast. It is not enough to ask, how windy is it? A careful person also asks, what is the tide doing? And perhaps, why did I think going out today was a good idea? Which is an underrated navigational question. The cold air over the North Sea can also create sudden showers, especially when very cold air passes over relatively warmer water. The sea adds heat and moisture to the lower atmosphere, and unstable air can rise, forming showers that may include hail, sleet, or snow in winter. These showers can be localized, meaning one area may be in clearer weather, while another is hit by poor visibility and gusty winds. From a distance, showers may look like dark curtains hanging beneath clouds. From inside them, they feel less decorative. Local effects can matter too. Coastlines shape wind, estuaries channel it. Land and sea temperature differences can influence breezes. Around offshore platforms and wind farms, the practical experience of weather is also shaped by structures, operations, and exposure. A forecast may describe a region, but a person working on a particular deck, at a particular height, at a particular moment, experiences a very specific version of that forecast. Weather is regional in reports and personal in impact. For helicopter flights to offshore platforms, weather can become a limiting factor in several ways. Wind, visibility, cloud base, icing, and sea state all matter. For supply vessels, rough seas can make transfers dangerous. For fishing boats, gear can become hazardous to handle. For ferries, passenger safety, docking, and route decisions all depend on the conditions. For lifeboat crews, the weather is not just something to avoid, it is often the reason they're going out in the first place, which is a rather unfair arrangement, but rescue work has never been built around fairness. The North Sea's weather also carries psychological pressure. A storm forecast changes decisions long before the first strong gust arrives. Fishermen weigh whether to leave, return, or remain. Port authorities adjust operations. Offshore managers decide whether work can continue. Ferry companies monitor routes. Coastal residents watch tide times. There is a whole chain of human response tied to the movement of air over water. A storm is not just an event. It is planning, waiting, checking, worrying, acting, and sometimes regretting. Earlier generations had far less warning. They read clouds, pressure, birds, swell, wind shifts, and experience. Sometimes they were right. Sometimes the sea changed too quickly or too severely. Wooden vessels, sail power, limited communication, and poor forecasting made weather one of the great killers. A storm could scatter fleets, drive ships onto banks, smash vessels against coasts, or leave families waiting for sails that never returned. The North Sea's fishing communities carry deep histories of weather loss, not because people were careless, but because the sea was hard, the work was necessary, and the tools were limited. There is a particular sadness in weather disasters, because they often begin as ordinary labour. People go out because going out is the work. Fish must be caught, cargo must move, a ship must reach port, a platform must be supplied, a crossing must be made. Weather turns, and suddenly the ordinary becomes dangerous. The North Sea is full of that kind of story. It has never been a stage for adventure alone. It has been a workplace, and workplaces can become deadly when the environment has more power than the people inside it. Even on land, the weather blowing off the North Sea can feel severe. East Coast towns know the cold push of wind from the water. Rain can arrive sideways. Sea foam can blow across promenades. Waves can overtop sea walls. During storms, people gather to watch the water, because humans have a long and questionable tradition of standing near dangerous things while saying, "Look at that." Authorities may close roads, warn people away from coastal paths, and ask them not to take risks. The sea can be impressive from shore, but impressive is not the same as safe. One of the North Sea's subtler dangers is that it can change after people have already committed themselves. A vessel at sea cannot always simply stop. It may need hours to reach shelter. A small boat may be too far from harbour when conditions worsen. A ship may be constrained by traffic lanes, depth, cargo or port schedules. Weather at sea is not like weather on land, where one can usually go indoors, complain about the rain, and make another cup of tea. At sea, the room is moving with you, and the outdoors has come inside. That is why timing matters so much. A forecast of gale later is not just a piece of information, it is a decision point. Later than what? Later than departure, later than return, later than the tide turning, later than the crew finishing work, later than the safe window for crossing a bar or entering harbour. The word later can be a trap if treated casually. The North Sea has no interest in personal schedules, and it has never once delayed a gale because somebody was nearly finished. Weather also becomes more dangerous when it is underestimated because the North Sea looks familiar. People know it. They see it from seaside towns, ferry terminals, holiday beaches, oil industry maps, and weather forecasts. Familiarity can soften fear, which is useful for daily life but risky at sea. A person might think it is only the North Sea, not the open Atlantic, but only is doing dangerous work there. The North Sea may be smaller than an ocean, but it is large enough to build serious weather and shallow enough to turn that weather into steep, punishing water. The sea's colour often adds to its mood. Under cloud, it can become a heavy grey-green or brown-grey, especially where sediment is stirred. Whitecaps appear quickly in fresh winds. Under a low sky, the line between water and cloud can blur until the world seems made of different kinds of grey moving at different speeds. It is not the bright drama of tropical seas. It is colder, flatter, more practical, and in some ways more intimidating. A tropical storm may announce itself with spectacle. A North Sea gale can look like the whole day has become wet metal. But there is beauty in it too. Not soft beauty, perhaps. Not postcard beauty, unless the postcard is being sent by someone with strong boots and a high tolerance for drizzle. It is the beauty of power made visible, cloud racing over open water, light breaking suddenly through rain, waves changing colour as the wind shifts, ships appearing and disappearing in weather, gulls holding themselves in the air with tiny adjustments, making aircraft look slightly over-designed. There is a reason people live beside it, work on it, paint it, write about it, and keep returning to its edge. To call the weather dangerous is not to call it meaningless. It is part of the system that makes the North Sea what it is. The same winds that build rough seas also mix nutrients. The same storms that threaten coasts also reshape beaches and move sediment. The same pressure systems that make sailors check forecasts give this region its changing skies. The North Sea is not separate from weather. It is weather made visible on water. Still, for those who cross it, work it, and guard its coasts, respect is practical. Weather is checked because lives depend on it. Forecasts are repeated because one missed detail can matter. Gale warnings are issued because wind over shallow water is not a background inconvenience. The Met Office's sea forecasts and warnings are part of a long tradition of trying to translate an unstable atmosphere into words people can act on. That translation is never perfect, but it is essential. So when we ask why the North Sea is one of the world's deadliest waters, the weather gives us a large part of the answer, not because it is always extreme, but because it changes often, combines hazards efficiently, and works over a sea already shaped for trouble. Wind builds waves, shallow water steepens them, tide complicates them, cold makes mistakes costly, fog hides danger, storms raise water, and through it all, ships and people continue to move, work, decide, and hope their timing is right. Picture a vessel now, somewhere out beyond the lights of shore. The seabed is shallow beneath it, the tide is running, and the forecast has been checked more than once. The morning was grey but calm enough. By afternoon the wind has freshened, the waves have grown shorter and steeper, rain crosses the deck and bursts, the horizon fades and returns. Nothing about this is mysterious in the supernatural sense. Every part of it can be explained by pressure, wind, water depth, and current. And yet, for the people inside it, the change feels alive, immediate, and deeply serious. The North Sea does not need to surprise the instruments in order to surprise the person standing on deck. That is one of its oldest lessons. The weather may be forecast, named, measured, and mapped, but when it arrives across cold, shallow water with the tide underneath and the wind pressing hard above, it becomes more than data. It becomes motion. It becomes noise. It becomes the reason hands grip rails and eyes keep returning to the horizon. And beneath that weather, the water is never still. Even when the sky eases, the sea keeps moving. Tides rise and fall. Currents run through channels and around banks. Hidden forces tug at hulls, buoys, nets, and anything unlucky enough to enter the water at the wrong place. The weather may change the mood from above, but the North Sea's next danger is already working below the surface, pulling, turning, and carrying the water along paths that are not always obvious from the deck. Beneath that weather, the North Sea keeps moving whether the sky's calm or furious. Wind may change the mood of the surface, but tides and currents are the deeper routine. They are the regular pull, the hidden traffic, the steady movement of water that never really clocks off. Even on a quiet day, with the horizon sitting neatly in place, and the gulls behaving as if they own the airspace the sea below is travelling. To someone watching from shore, the tide can look simple. The water comes in, the water goes out, the beach grows smaller, then larger again. Rocks appear and disappear. Children build sandcastles in places that the sea has already booked for later. It seems almost domestic, like the sea is breathing in and out beside the land. But offshore, and especially in a shallow sea like the North Sea, that rise and fall is only part of the story. Tides do not just lift water vertically, they also move it horizontally. They create currents, streams, races, eddies and flows that can carry boats, buoys, nets, sediment, wreckage, and sometimes people far from where they expected to be. Tides are caused by the gravitational pull of the moon and the sun acting on Earth's oceans. Around Britain, many places experience 2 high tides and 2 low tides each day, with the timing shifting from one day to the next. That sounds orderly enough, but once those tidal movements enter real coastlines, shallow basins, estuaries, banks, islands and channels, the pattern becomes much more complicated. The Met Office explains tides as the regular rise and fall of sea level, caused by the changing positions of the Earth, Moon and Sun, and notes that tides can be especially important at beaches because an incoming tide can leave people stranded. At sea, the same motion becomes a matter of navigation. The North Sea is not a still bowl filled with water that simply rises and falls. It is a broad shelf sea with water moving through it in response to tides coming in from the Atlantic, waves travelling around land masses, and the rotation of the Earth helping shape the pattern. The result is not one single push. It is a system of moving water with tidal streams that strengthen, weaken, reverse, and interact with the seabed. This is where the North Sea becomes less like a bath and more like a busy railway station, if the railway station were cold, grey, and occasionally tried to knock you sideways. Water is moving along routes. Some of those routes are broad and predictable. Others are local, fast and awkward. The current near a harbour entrance may behave differently from the current a few miles offshore. The water around a sandbank may speed up or turn. An estuary may empty strongly on the ebb tide, then fill again with equal determination. To a ship, these movements can help or hinder. To a small boat, they can decide the whole day. The difference between tide and current is worth pausing over, because the two are often spoken about together. Tides are the rise and fall of the sea surface. Currents are the movement of water from one place to another. NOAA describes tides as large waves moving through the ocean in response to the moon and sun, while currents are the back and forth or horizontal movement of water. Tidal currents are strongest near coasts, bays and estuaries, and in some places they can reach very high speeds. For a swimmer, a current can be frightening because it does not need to look dramatic to be strong. Water does not have to foam or roar in order to move you. A current can take hold quietly. One moment the shore seems comfortably close. A few minutes later it is at a different angle, and the person in the water is using energy faster than they expected. This is especially dangerous in cold seas because the body has less time and less strength to correct mistakes. The North Sea is not a warm swimming pool with lane ropes and a lifeguard chair at the end. It is cold, moving water with a schedule of its own. For boats, currents create a different kind of problem. A vessel may be pointing in one direction but moving partly in another. Mariners call this set and drift. The boat's heading is where the bow points. Its actual track over the ground is where the current, wind and engine power combine to carry it. On a calm lake, those may be almost the same thing. In the North Sea, assuming they are the same can put a vessel somewhere it did not mean to be. That might mean arriving late, burning more fuel, missing a safe tide, being pushed toward a bank, or finding that the approach to harbour has become much more interesting than anyone on board requested. The strength of North Sea tidal currents is one of the reasons it has such a dangerous reputation. Britannica describes the North Sea as hazardous, partly because of its strong tidal currents, and notes that tidal ranges along the British coasts and southern estuaries average roughly 4 to 6 metres. That is not a small amount of water shifting in and out of coastal spaces. It is a great volume moving on a regular cycle, and when that movement is squeezed around banks, headlands and estuaries, it can create difficult conditions for navigation. Think of an estuary at low tide. Mudflats glisten, channels twist through the exposed ground, boats rest at angles that make them look slightly embarrassed. Then the flood tide arrives. Water fills the channels first, then spreads across the flats, lifting boats, covering sand, and remaking the place in a few hours. To a walker, that incoming tide can be a trap. A route that looked open can vanish behind them. A channel that looked like a shallow stream can deepen and widen. That is why coastal warnings about tide times are not just fussy little signs placed by people who dislike adventure. They are there because the sea can return faster than a person can walk. Offshore, the same rise and fall becomes a horizontal force. The water has to go somewhere. It does not simply lift in place like a stage curtain. It runs through the basin. In the North Sea, the tidal wave travels around the region in a rotating pattern, influenced by the shape of the basin and the Coriolis effect. There are areas called amphidromic points, where tidal range is very small, while the tide rotates around them and the range grows farther away. That can sound oddly technical for a sleep-friendly evening, but the simple version is this. The North Sea's tides do not rise evenly everywhere at once. They turn, circulate, arrive at different times, and produce currents as they go. This matters because two places that are not very far apart can be at different stages of the tide. One harbour may be nearing high water, while another is still rising. One stretch of water may have the tidal stream running north, while another nearby area is already beginning to slacken or turn. For sailors, fishermen and pilots, this is practical information. It tells them when there is enough depth to cross a bar, when a current will help them, when it will fight them, and when a narrow passage may become unpleasant. The word slack water sounds comforting, as if the sea has decided to have a rest and perhaps a biscuit. It means the short period when the tidal current is weakest, often around the turn between flood and ebb. In some places, slack water is brief. In others, it may not line up exactly with high or low tide, which can surprise beginners. The water level may be high, but the current may still be running, or the tide may have turned on the surface while the flow below behaves differently for a time. The sea is not a clock face, even when we use clocks to predict it. Strong tidal streams are especially important when they meet wind. If wind and tide move in the same direction, the sea may still be rough, but the waves can sometimes stretch out a little. When wind blows against the tide, the surface can become steeper and more confused. The moving water shortens the waves and makes them stand up harder. In the North Sea, where waves are already affected by shallow depth, this combination can make conditions deteriorate quickly. A wind against tide sea does not need to be enormous to be dangerous. It only needs to be steep, close, and relentless. Imagine walking down a moving staircase while someone is pushing from the opposite direction. That is not a perfect scientific analogy, but it gives the general inconvenience. The tide is carrying water one way. The wind is trying to build waves the other way. The energy bunches up. Crests sharpen. The boat's bow meets wave after wave with less time to recover. For a large ship, this can mean uncomfortable motion and heavy spray. For a small vessel, it can become exhausting and unsafe. For someone trying to handle gear on deck, it can turn ordinary work into a test of balance, timing, and vocabulary. NOAA explains that wave height depends on wind speed, wind duration, and fetch, and that as wind-driven waves approach shallower water, friction with the seafloor makes them form steeper angles. In the North Sea, that general wave behaviour meets strong tidal movement and shallow banks, which is why the sea can become choppy and hard even without the huge long swell associated with deep oceans. Currents also move sediment. This is a quiet but important part of the North Sea's character. Sand, silt and mud are picked up, carried, dropped and picked up again. Over time, currents shape banks, channels, shoals and coastal flats. A chart is a snapshot of a moving place. Modern surveys update that picture, but the seabed still changes. Tidal currents help maintain the restless landscape below the surface. That landscape then shapes the water above it. It is a loop. The current moves the sand shapes the current. Everyone involved refuses to sit still. This is one reason the southern North Sea is so full of navigational complexity. Shallow waters and tidal streams interact with sandbanks that may be broad, long and close to the surface. Around these banks, the water can speed up or become disturbed. Waves crossing a bank may grow steeper as depth decreases. A vessel passing near one in poor weather may find that the sea state changes noticeably over a short distance. The bank is not visible from the deck, but the water knows it is there. Fishermen have always paid attention to these movements. Fish gather where currents bring food. Nets and lines behave according to flow. A trawler working near a bank or channel must think about tide as much as catch. The sea's hidden pull affects where gear goes, how it lies, and how safely it can be recovered. A net caught or dragged in a strong current can become dangerous. Heavy gear under tension is no joke, even if the person describing it later may use jokes, because that is what people do when work is hard and the tea is bad. Offshore construction also has to respect currents. Oil and gas platforms, pipelines, cables and wind farms all exist in water that moves. Engineers must think about scour, the way currents remove sediment from around structures. They must consider how tidal flows affect installation, maintenance, vessel positioning, and long-term stability. A turbine foundation, a cable route, or a pipeline crossing is not placed in a blank blue space. It is placed in a shallow, energetic sea, where the bottom and the water keep adjusting to each other. The North Sea's currents are not only tidal, there is also residual circulation, which means the smaller net movement left over after the back and forth tidal motion is averaged out. This is important for mixing, temperature, nutrients, larvae, pollution, and sediment transport. Research on the Northwest European shelf has shown that tides contribute to large-scale residual circulation and mixing in shelf seas, including the North Sea region. For a bedtime listener, residual circulation may sound like something found at the bottom of a washing machine, and in a way that is not entirely unhelpful. The water sloshes back and forth with the tide, but over time there can still be a net transport. Things drift, nutrients move, pollutants spread, tiny marine organisms travel, sediment shifts from one area to another. The sea is not just moving in daily cycles, it is slowly exchanging, mixing and redistributing. Hydrodynamic studies of the North Sea focus heavily on tides, storm surges, and their associated currents because these movements can be very strong. A Science Direct summary of research on residual circulation notes that hydrodynamic models of the North Sea are concerned with tides, storm surges, and associated currents, which can reach velocities of several meters per second in some contexts. That is fast enough to matter greatly. A few meters per second may sound modest beside cars and trains, but for water, it is powerful. Water is heavy. Moving water is persuasive. Moving water with depth, volume and tide behind it is not something anyone wins an argument with. This hidden pull also complicates rescue. If someone falls overboard, they may not remain where they entered the water. Wind pushes from above. Current carries from below. Waves hide and reveal. Cold weakens the body. A search area grows larger with time. Rescue crews must calculate drift, and that drift may change as tide turns. The North Sea's currents do not pause for emergencies. They continue their cycle, which means time becomes very important very quickly. The same is true for objects lost from ships, containers, fishing gear or debris after an accident. Where will it go? The answer depends on wind, current, tide, buoyancy, and time. Sometimes things wash ashore far from where they were lost. Sometimes they sink and become part of the seabed story. Sometimes they drift through busy waters and become hazards themselves. The North Sea has carried pieces of human activity for centuries, from wreckage to cargo to messages in bottles, though the bottles, being glass and optimistic, tend to receive more romance than most floating litter deserves. Tidal currents also affect harbour access. Many ports around the North Sea are built around tidal windows. A large vessel may need enough depth to enter safely. A pilot may board at a certain time. A ship may wait offshore for the right water. In narrow channels, currents can make steering more difficult, especially for deep draft vessels with little room under the keel. When a large ship moves through shallow water, its handling changes. Add cross-current, wind, and traffic, and the job becomes highly skilled. To the person watching from shore, a ship entering port may look slow and almost effortless. On the bridge, it is a calculation in motion. Ferries crossing the North Sea also work with tide and current, though passengers may mostly notice whether the coffee stays in the cup. A ferry route may be planned with currents in mind, especially near port approaches. Strong tidal streams can affect arrival time, fuel use and docking. In rough weather, current against wind can make the crossing more uncomfortable. This is one reason a forecast that mentions wind direction and sea state matters even to people who are not steering. Their stomachs may still take a professional interest. The pull beneath the surface becomes even more serious near coasts with tidal flats. Places like the Wadden Sea along the Netherlands, Germany and Denmark are shaped by tides, channels, mudflats, barrier islands and shallow water. These environments can be beautiful, rich with bird life and marine life, but they are also places where tide timing matters. Channels fill, flats flood, fog can settle. A person walking far out on exposed ground may find the water returning through channels behind them before the whole flat is covered. The danger is not always a wave knocking someone down. Sometimes it is the route home disappearing. This is a useful reminder that the North Sea's deadliness is not limited to sailors in storms. It can involve coastal walkers, swimmers, anglers, kayakers, paddleboarders, and people who misjudge tide times. A calm day can still be dangerous if the tide is moving fast through a channel or returning across flat sand. Many coastal rescues begin not with wild weather, but with ordinary underestimation. The sea does not need drama to create risk. It only needs movement and time. There is also a strange psychological problem with currents. We are built to notice visible threats. A breaking wave gets attention. A dark storm cloud gets attention. A current does not always announce itself. The surface may show only small ripples, lines of foam, a change in colour, or nothing obvious at all. People may step into water that looks manageable, and then discover that the force is not where they expected it. This is why local knowledge matters so much. Signs, lifeguards, harbour masters, fishermen, and experienced sailors know places where the water runs hard. The danger may be familiar to them and invisible to visitors. The North Sea is also connected to larger circulation patterns. Water enters from the Atlantic, moves through different parts of the basin, mixes with river water, and exits through other routes. The details are complex, and scientists model them carefully because they affect ecosystems, pollution, climate studies, fisheries, and coastal management. But for this journey, the key point is simple enough. The North Sea is not a pond. It is open, connected, stirred, and moving at different scales all at once. There is the half-day rhythm of tides. There is the shorter disturbance of wind-driven current. There is the longer movement of residual circulation. There are storm surges. There are local eddies around banks and coastlines. The water is never doing just one thing. Storm surge is another form of hidden pull, though it becomes very visible when it reaches land. Strong winds and low pressure can push and raise the sea surface, driving water toward coasts. If this happens during high tide, levels can rise dangerously. The 1953 North Sea flood showed how destructive this can be, especially around low-lying coasts in the Netherlands and eastern England. A surge is not the usual tide behaving politely. It is weather adding extra water level on top of the astronomical tide, and the North Sea's shallow, narrowing southern basin can make that worse. For ships offshore, a surge may not feel like a wall of water. It may simply be part of a larger storm system with high water, rough seas, and strong currents. For the coast, it can mean overtopped defences, flooded land, and water entering places that normally trust the sea to stay outside. This is where tides and weather become inseparable. The tide sets the stage. The storm adds height and force. The coastline either holds or it does not. The North Sea's tidal nature has also shaped human habits. Ports, fishing schedules, ferry operations, beach warnings, rescue planning, flood defences and coastal engineering all depend on knowing what the water is likely to do. Tide tables are not quaint old maritime decorations. They are predictions of a major physical process. People consult them before launching boats, walking tidal routes, crossing causeways, entering harbours, dredging channels and planning work near the shore. A tide table is the sea's appointment diary, though it is worth remembering that the sea never apologises if the appointment is inconvenient. There is a quiet beauty in how predictable tides can be and how dangerous they remain. We can calculate high water, we can publish tide times months ahead. We can model currents, map banks, and forecast surges. Yet the experience of moving water is still immediate and physical. A tide can be predicted and still catch someone out. A current can be charted and still overpower a swimmer. A harbour entrance can be well known and still become difficult when wind, tide and wave meet at the wrong angle. Knowledge is essential, but it is not the same as immunity. For those who work on the North Sea, respecting the tide becomes almost instinctive. It affects when to leave, where to fish, how to cross a bank, when to enter port, how to anchor, how to recover gear, how to plan a transfer and when to wait. Waiting is not failure at sea. Often it is wisdom wearing a raincoat. The tide may be wrong now, but better later. The current may be too strong now, but slacken soon. The sea may not reward impatience, but it sometimes rewards the person who has brought sandwiches and enough sense to use them. At night, currents become harder to read visually. The darkness hides texture. Lights can confuse distance. A buoy's movement may show the flow, but only if you can see it clearly. Radar and instruments help, yet the sense of water moving beneath the hull remains important. A vessel may feel different as it crosses a current line. The engine note, steering response and motion can all change. Experienced mariners notice such things. The sea speaks in small practical details, not in grand speeches. During storms, the hidden pull becomes part of the chaos. A vessel may be pushed by wind, carried by current, lifted by waves, and constrained by depth all at once. If power is lost, the current decides much of what happens next. Drifting toward a lee shore, a bank or a traffic lane can turn a mechanical problem into an emergency. Anchoring may be difficult in poor holding ground or strong current. Towage may be complicated. Rescue may be delayed by sea state. Again, the danger is layered. The current alone may not be deadly. The current plus wind, cold, darkness, shallow water, and limited time may be. This is why the North Sea's move in water deserves as much attention as its storms. Storms are dramatic. Tides are routine. But routine forces can be just as dangerous because people begin to treat them as the background. The tide is always there, so it becomes easy to forget how strong it is. The current has turned every day for centuries, so it becomes ordinary. Yet the ordinary sea is still powerful. It does not need a special occasion to move millions of tons of water around a coast. There is a simple way to think about it. The North Sea is not a surface. It is a volume in motion. From the beach, we see the top. From a chart, we see depths. From a forecast, we see wind. From a tide table, we see times and heights. From a current atlas, we see arrows. The danger lives in how those pieces overlap. A shallow bank under a fast tide, a strong wind against an ebbing current, a harbour entrance at the wrong stage of tide, a swimmer caught in a flow they cannot see, a storm surge arriving with high water. Each part is understandable. Together they create a sea that demands attention. Now picture the North Sea on a quieter evening. No gale for the moment, no dramatic storm cloud. Just low grey light, a line of ships far offshore, and water moving with steady purpose. The tide is running along hidden channels. Sand is being lifted and laid down somewhere below. A buoy leans in the current. A fishing boat works its gear while watching the time. Farther south, water creeps across mudflats. In a harbour, a pilot checks the next movement. On a beach, the wet sand shines where the sea has just left, though it is already planning its return. Nothing about this looks especially violent. That is the point. The North Sea's danger is not always in what can be seen from a distance. It is often in the pull beneath, the current around the bank, the tide filling the channel, the water hurrying where the surface looks calm. And once those currents meet the shifting floor of the southern sea, the hazards become even more particular. Because below the waves there are banks, shoals, ridges and channels that do not merely sit there as scenery. They move, change, redirect water, and wait just beneath the surface, turning the next part of the sea into a map that never stays completely still. The water is not the only part of the North Sea that moves. The floor moves too. Not all of it, of course. The whole seabed is not sliding around like a rug under a nervous dog. There are deeper formations, harder layers, old glacial deposits, clay, gravel, rock, and buried landscapes that remain broadly in place. But in the shallow southern North Sea especially, the sand does not behave like a fixed floor. It shifts, it builds into banks, it thins into channels, it is lifted, pushed, dropped, and rearranged by tides, currents, waves, and storms. From the surface, the sea can look like a wide grey plain. Beneath it, there is a landscape that keeps being edited. This matters because a hidden moving landscape is not just interesting, it is dangerous. A rock is at least a rather honest hazard. It may be rude, it may be sharp, it may sit exactly where a ship would prefer it not to sit. But a rock has a certain commitment to place. A sandbank is different. It can change shape. It can creep. It can grow at one end and erode at another. Channels can deepen, shallow, open, or close. A bank that was safely covered by enough water may become more troublesome after a storm. A passage that generations of sailors used with confidence may need new surveys, new marks, and new caution. The sea above a bank may look like ordinary water, but the keel of a vessel has a much more personal relationship with the truth below. The southern North Sea is especially known for these shallow and shifting banks. Britannica describes the North Sea's southern depths as generally less than 120 feet, or about 35 metres, and notes that many shallow shifting banks in the south have been reworked by tidal currents and present serious navigational hazards. That one sentence contains a large part of the North Sea's character. Shallow water, moving sediment, strong currents, hazard for ships. All quietly waiting beneath the surface while the sky gets the dramatic lighting. To understand why this is so important, imagine a ship crossing what appears to be open sea. There is no cliff, no reef breaking the surface, no island, no lighthouse directly ahead. Just water, weather and route. But beneath the hull, the seabed rises. It may rise gently, almost politely over many miles, or it may form a sharper shoal where the depth drops quickly. The vessel's crew may know this perfectly well from charts, instruments, and planning. Modern navigation is not guesswork, but the danger is still there, especially when weather is poor, visibility is low, traffic is heavy, or the water is being pushed by tide and wind. The issue is not only that a ship might touch the bottom, though that is serious enough. The bank changes the water above it. Waves crossing from deeper to shallower water are slowed by the seabed. Their length shortens, their height can increase, and they can become steeper. This is the same basic reason waves rise and break as they approach a beach, although offshore banks create their own versions of that process. A vessel crossing a shallow bank in rough weather may find the sea suddenly sharper and more confused. The water has less room beneath it, so its energy changes shape. A patch of sea that looked manageable in deeper water can become hard and choppy over a shoal. This is where the North Sea's hazards begin to stack on top of each other. The tide is already moving. The wind is already building waves. The seabed suddenly rises. The water shallows. The waves steepen. If wind and tide oppose each other, the sea becomes steeper still. If visibility drops, the crew's workload increases. If the ship is large, deep drafted, or constrained by traffic lanes, there may be limited room to manoeuvre. If the vessel is small, the motion itself may become unsafe. The sandbank is not acting alone. It is part of a system that turns small mistakes, bad timing, or bad luck into real danger. The most famous of the North Sea's underwater banks is Dogger Bank. It lies about 100 kilometres off the northeast coast of England and is one of the great raised features of the sea. Britannica describes it as an extensive isolated shoal, about 260 kilometres long and 60 kilometres wide at the 35-metre level, with its shallowest point about 15 metres below the sea surface. It rises around 20 metres higher than the surrounding sea floor and is a huge moraine deposited at the southern limit of the last glaciation. That word moraine takes us back to ice. During colder periods, ice sheets advanced and retreated across this region, carrying and leaving behind clay, stones, sand and other material. The North Sea has not always been the sea we know today. Parts of its basin were once land, rivers crossed areas now covered by water. People and animals lived in landscapes that later disappeared beneath rising seas. Dogger Bank is a remnant of that older, colder history, now sitting underwater as a raised bank where fish gather, currents pass, and waves change their behaviour. For centuries, Dogger Bank has been known as a productive fishing ground. Britannica notes that large amounts of food available to fish there have supported catches of plaice, cod, haddock, turbot, dabs, and herring. That makes sense. Shallow banks can be rich places. Currents bring nutrients. The seabed supports small animals. Fish follow food and fishermen follow fish. This is one of the North Sea's recurring bargains. The dangerous places are often useful places too. A bank that complicates navigation may also support life. A shallow sea that can punish vessels also feeds communities. Dogger Bank is not just a hazard or a fishing ground. It is also an ecological area. Germany's Federal Agency for Nature Conservation describes the Dogger Bank as the largest sandbank in the North Sea, stretching more than 320 kilometres from the continental shelf of the United Kingdom into the marine areas of the Netherlands, Germany and Denmark. The German Nature Conservation Area alone covers 1,624 square kilometres at depths from about 29 to 48 metres. The agency also notes that sandbanks covered by seawater may look uniform at first, but different sediment grain sizes, depths and currents support varied communities of organisms. That is worth remembering. To a ship, a bank is a navigational feature. To a fisherman, it may be a working ground. To a biologist, it is habitat. To a sailor in bad weather, it may be the reason the water suddenly becomes unpleasant. The same place has different meanings depending on who is crossing it, studying it, or trying not to spill soup while passing over it. And Dogger Bank is only the famous name. The North Sea contains many other banks and shoals, especially toward the south and along coastal approaches. Some are broad, some are long, some are close to busy shipping routes, some are tied to estuaries and coastal sands. Together they make the seabed feel less like a floor and more like a low, drowned landscape, with ridges, lanes, shelves, and traps. The trouble is that the landscape is hidden by water, and water is very good at pretending there is nothing underneath. A shoal is simply an area where the water becomes shallow enough to matter. A sandbank is a raised area of sand or sediment, often formed and shaped by waves and currents. Britannica describes a sandbar as a submerged or partly exposed ridge of sand or coarse sediment, built by waves offshore from a beach, with sand moved by turbulence, backwash, rip currents, and waves. It also notes that bars can migrate shoreward in gentle seas and seaward in high seas. That movement is the important part. Sandbanks are not frozen monuments. They are forms made by motion, and motion can remake them. In the North Sea, tidal currents are strong enough to rework banks over time. Storm waves can reach down toward the seabed in shallow water and move sediment. Winter storms are especially effective because they bring stronger waves and more energy. The result is not that every bank leaps across the chart in a night. The sea is not performing magic tricks for hydrographers, but changes can be large enough to matter, especially in channels, shallow patches, and areas where ships need reliable depth. This is one reason hydrographic surveying is so important. Charts not made once and then left to grow old in peace. Survey vessels, sonar systems, satellites, tide gauges, and modern mapping tools all help keep track of seabed change. A chart is a conversation between the sea and the people trying to cross it safely. The sea changes, people measure. The sea changes again, people update. It is not glamorous work in the way a storm rescue looks glamorous from a distance, but it is one of the reasons modern navigation is possible. Older sailors did not have this advantage. They had lead lines, local knowledge, landmarks, early charts, buoys, lights, soundings, and experience. A lead line was simple and brilliant. A weighted line lowered to measure depth, often with material on the bottom of the weight to bring up a sample of the seabed. Sand, mud, shell, gravel. These details helped a navigator know where they were. It was slow, practical work, and in poor weather it could be difficult. Imagine trying to read a hidden landscape by lowering a weight into moving water while the vessel rolls, the wind rises, and the coast is somewhere in the fog. It makes modern, electronic charts look less like convenience and more like mercy. Yet even with modern tools, the banks remain serious. Large ships today are huge, and many need carefully maintained channels. A container ship, tanker, bulk carrier, or ferry may have a deep draft and limited room under the keel in some areas. Underkeel clearance is not just a number for people who enjoy paperwork. It is the difference between water beneath the ship and expensive scraping noises. In shallow seas, the movement of the vessel itself, the squat effect, tide height, wave motion, and seabed uncertainty all matter. A ship moving through shallow water can sit lower in the water because of hydrodynamic effects, reducing clearance. Add waves, and the vertical motion of the ship can bring the keel closer to the bottom. This is why pilots and navigators treat shallow passages with such care. For smaller vessels, banks create different problems. A fishing boat or yacht may not draw as much water, but it is more vulnerable to steep seas. As waves cross a bank, they may become short and breaking. A small boat can lose speed, take water over the bow, or become difficult to control. If the engine fails, the tide may carry the boat towards shallower water. Anchoring near a bank in bad conditions may be risky. Nets and gear can snag. A useful fishing ground can become a hard place to escape from if the weather changes. Sandbanks also matter because they can hide wrecks, and wrecks can change the local seabed. The North Sea is full of maritime history, which is a polite way of saying many things have sunk there. Wooden ships, steamers, warships, fishing vessels, aircraft wreckage, lost anchors, cargo, and modern debris all lie in its waters. Some wrecks become marked hazards, some become artificial reefs, some are buried and uncovered again by shifting sediment. A wreck that is covered by sand for years may reappear after storms. Another may slowly vanish beneath sediment. The seabed is not only geology, it is history being covered and uncovered. There is something unsettling about that. A ship can be lost, forgotten by most people, then partly revealed again by a change in sand. The North Sea keeps records, but it files them badly. A storm may open the drawer, a tide may close it again. Archaeologists, divers, fishermen and surveyors all know that the seabed can reveal surprises. Some are scientifically valuable, some are dangerous. Unexploded ordnance from the world wars remains a concern in parts of the North Sea. Old wrecks may contain fuel, cargo or structural hazards. The moving sand does not distinguish between treasure, tragedy and nuisance. The Goodwin Sands, near the Dover Strait rather than the central North Sea, offer a useful example of what shifting offshore sandbanks can mean for navigation in the wider waters connected to the North Sea routes. A 2026 report described the Goodwin Sands as a 16-kilometre bank close to busy shipping lanes, historically linked to about 2,000 vessel losses, and noted that offshore banks can shift during winter storms as waves erode one side and deposit sand on another. The same report gave an example of one North Sea bank moving 70 metres in 50 days. That is the kind of detail that makes a sandbank feel less like scenery and more like an active participant. 70 metres may not sound like much on land if you're thinking about a walk in the park. At sea, in shallow water, near a route that depends on charted depths, it matters. A channel edge shifts, a shallow patch extends, a buoy may need moving, a survey may need updating, a pilot may need new information. A vessel following old assumptions may find that the bottom is not where it was expected to be. This is one of the reasons maritime safety has always depended on systems, not just individual skill. Buoys, beacons, lighthouses, charts, notices to mariners, traffic separation schemes, dredging, hydrographic offices, harbour authorities, pilots and coastguards all form part of the safety net. The North Sea's moving seabed requires a moving body of knowledge. People must keep checking because the sea keeps changing. The old image of a lighthouse standing above dangerous rocks is still important, but sandbanks need a different kind of attention. Rocks can be marked once and watched. Sandbanks demand repeated measurement. A buoy marking a channel has to correspond to what the water and seabed are actually doing now, not what they were doing when someone's grandfather learned the route. This is not disrespectful to grandfathers, who often know a great deal and are usually willing to explain it at length. It is simply that sand does not honour tradition. The North Sea's tidal energy also means that banks can form long streamlined shapes. These are sometimes called tidal sand ridges or tidal sandbanks. They tend to align with the prevailing tidal currents and can stretch for many kilometres. Their shape reflects the flow of water over the seabed. In other words, the sand is a record of movement. The bank shows where the current has been strong, where sediment has gathered, and how the seabed has adjusted to repeated forcing. It is a map drawn by water, though unfortunately not always in a handwriting convenient for ships. Where banks lie near the surface, waves can break over them during rough weather. This can be extremely dangerous, because breaking water offshore may be unexpected by those who do not know the area. The sea may appear rough everywhere, but over a bank it may become rough in a different way, with standing waves, confused crests, and sudden breaking. A vessel caught there may have little room to recover, especially if the tide is also setting it toward the hazard. It is one thing to meet rough sea in open water. It is another to meet rough sea where the bottom is rising. The seafloor also affects how storm energy reaches the coast. Banks can absorb, redirect, or focus wave energy. Channels can guide water. Shallow flats can slow waves, but also allow surges to spread across low areas. Coastal engineers study these features because they affect erosion and flooding. A sandbank offshore may offer some protection under certain conditions, while under others the system may change in ways that increase risk somewhere else. The coastline is not separate from the seabed. They are parts of one moving edge. People living along the North Sea have always had to negotiate with this edge. The Netherlands, Germany, Denmark, Eastern England, Belgium and northern France all have coastlines shaped by sand, mud, tide and storm. Dunes, barrier islands, tidal flats, estuaries, salt marshes and reclaimed land all show the long struggle between water and ground. The Wadden Sea, along the Dutch, German and Danish coasts, is one of the clearest examples of a landscape that changes with tide and sediment. At low tide, huge areas of mudflat and sandflat are exposed. At high tide, they disappear beneath water. Channels run through them like veins. It is beautiful, productive, and not to be treated casually. The danger of such places is often timing. A person walking on exposed flats may feel safe, because the ground is solid enough and the shore looks near enough. Then the water returns through channels, sometimes behind them. Fog may come down, the route may vanish. The incoming tide does not need to rush like a breaking wave to trap someone. It only needs to be steady, broad, and faster than expected. This kind of danger is quiet and practical, which is perhaps why signs and local guides repeat the warning so firmly. The sea is not trying to frighten anyone. It is just keeping its appointment. For ships, the danger is depth. For walkers, it is returning water. For fishermen, it is gear, tide, and weather. For engineers, it is scour and shifting sediment. For ecologists, it is habitat change. For historians, it is the burial and exposure of wrecks and drowned landscapes. One sandbank can mean all of these things at once. The North Sea's seafloor is not a background. It is part of the action. There is also something humbling about the scale of change. Humans build ports, seawalls, wind farms, pipelines, and navigation systems. We dredge channels, nourish beaches, mark hazards, and model currents with powerful computers, and still sand moves. Not because it is dramatic, but because the forces never stop. Every tide has a little work to do. Every storm has more. Grain by grain, ridge by ridge, season by season, the seabed adjusts. The movement may be slow compared with a breaking wave, but over years and decades it can redraw the underwater map. This is why shifting sands is not just a phrase for uncertainty. In the North Sea, it is a physical fact. It affects the routes ships take, the places fish gather, the safety of offshore structures, the shape of coastlines, and the work of everyone responsible for keeping navigation charts accurate. It is one of the reasons the North Sea can remain dangerous, even when every visible object has been marked, mapped, and named. The hazards below are not always where a casual glance expects them to be. From the deck of a vessel, there may be no sign of any of this until the instruments show it, or the sea state changes. The echo sounder begins to show less water beneath the keel. The chart shows a bank ahead. The wave pattern tightens. The tide begins to set across the planned course. The crew adjusts. They may have done it 100 times. It may be routine, but routine at sea is not the same as harmless. Routine is simply danger that has been studied carefully enough to work around. And that is perhaps the most important point. Sandbanks and shoals do not make the North Sea deadly because they are mysterious in the old mythical sense. They make it deadly because they are physical, measurable, and unforgiving. Their locations matter. Their depths matter. Their movement matters. Their effect on waves and currents matters. If ignored, they can damage a ship as effectively as a storm. If misunderstood, they can turn a navigable route into a trap. If combined with bad weather, poor visibility, or strong tide, they can make the sea suddenly much harder than it looked a few miles earlier. So the North Sea's hidden floor keeps working below the waves. Dogger Bank rises broad and shallow from glacial history. Southern banks are reworked by tidal currents. Coastal bars form, shift, and migrate. Channels carry water through sand and mud. Wrecks appear and disappear. Surveys update what sailors need to know. And above all of it, ships pass, crews watch, engines turn, and the sea continues its patient rearrangement of the ground beneath them. Now imagine the same grey evening again, but lower your view beneath the surface. Below the waves, the light fades quickly. The water is full of fine, suspended sediment. The bottom appears, not as a neat floor, but as ripples, slopes, shells, sand, mud, and long raised banks stretching away into dimness. The tide moves over them, grains lift and settle, a channel edge crumbles slightly. Somewhere farther off, a wreck lies half buried, its shape softened by years of sand. Above it, a ship passes safely because someone measured, marked, planned, and paid attention. Yet even good charts and careful planning depend on seeing, and seeing is not always easy on the North Sea. The seabed hides below. The weather lowers from above. Fog can erase distance. Rain can flatten the horizon. Darkness can turn water, sky and shore into a set of uncertain lights. Once the moving floor has done its quiet work, another danger waits at eye level, where the world can vanish not because it is gone, but because the sea and air have simply stopped letting you see it. Once the seabed, the tide and the weather begin working together, the North Sea already has enough ways to cause trouble, but there is another danger that does not push, pull or break over the bow. It simply removes the world. Fog. Darkness. A horizon that was there a moment ago then is no longer useful. At sea, visibility is not a small detail. It is one of the foundations of safety. A clear horizon gives the eye something to measure against. It lets a crew judge distance, weather, traffic, land, wave direction, and the shape of the day ahead. When visibility collapses, the sea does not become more dangerous because it has changed its strength. It becomes more dangerous because people have lost part of their ability to understand it. On land, fog can be inconvenient. It slows roads, delays flights, turns familiar streets into pale corridors, and makes every tree look as if it is arriving from a mystery novel. At sea, fog has sharper consequences. It hides other vessels, it hides buoys, it hides coastlines, it hides the entrance to harbour, it hides the direction from which sound is coming. It hides the simple visual clues that human beings rely on without thinking. The water may still be moving in the same way. The ship may still be functioning perfectly. But the space around it becomes uncertain. The Met Office defines fog as a cloud at ground level that reduces visibility to less than 1,000 metres, with dense fog reducing visibility below 100 metres. That is not much room at sea. A ship travelling at normal speed can cover that distance quickly, and a large ship cannot stop like a bicycle. It has weight, momentum, cargo, windage, draft, and a stopping distance that can be far longer than anything the eye can see in fog. Sea fog is especially relevant to the North Sea because of the way warm, moist air can move over cooler water. The Met Office explains that advection fog occurs when moist warm air passes over a colder surface and cools, and it notes that coastal fog is frequent along the UK's east coast in spring and summer, often known as HAR. This commonly happens when warm air moves over the cool surface of the North Sea toward the east coast. That word, HAR, belongs to eastern Scotland and parts of the North Sea coast. It sounds soft enough, almost polite, but anyone who has watched it arrive knows it can be very thorough. A bright day can lose its edges. The sea turns pale. The beach disappears at both ends. Buildings fade. A harbour that was clear becomes a set of muffled shapes. The air feels damp, cool and close. People inland may still be enjoying sun while the coast sits under a grey blanket, wondering what it did to deserve this. For ships, fog is not only about seeing less. It is about having to work harder with every other sense and instrument. Radar becomes more important. AIS becomes more important. Sound signals matter. Lookouts matter. Safe speed matters. The international regulations for preventing collisions at sea require vessels to maintain a proper lookout by sight, hearing, and all available means appropriate to the circumstances, and to proceed at a safe speed, taking visibility and traffic density into account. In restricted visibility, vessels must use a speed adapted to the conditions and have engines ready for immediate manoeuvre. That language sounds formal because it needs to be. It is the language of preventing heavy objects from meeting in cold water. A proper lookout is not just someone glancing out of a window when they remember. It means actively using eyes, ears, radar, instruments, and judgment to understand what is around the vessel. In fog, the bridge becomes a place of listening, watching screens, checking plots, comparing data, and making cautious decisions before the situation has become urgent. This is where the North Sea's busyness matters again. Fog over empty water is one kind of danger. Fog over a crowded working sea is another. The North Sea has major shipping routes, fishing vessels, ferries, offshore supply vessels, tankers, container ships, wind farm service craft, pilot boats, military vessels, and anchored ships waiting near ports. It also contains platforms, wind farms, buoyed channels, traffic separation schemes, and approaches to some of Europe's busiest harbours. Poor visibility does not remove any of those things. It simply makes them harder to sort out. Imagine standing on the bridge of a ship in fog. The windows show a pale grey wall. The sea surface may appear for a short distance, then vanish. The horizon is gone, so the eye has less sense of scale. Radar shows targets, but each target must be interpreted. Is it moving? Is it anchored? Is it crossing? Is it a fishing vessel with gear out? Is it a buoy? Is it rain clutter? A IS may provide information from other vessels, but not everything always appears neatly, and not every small craft carries or transmits what a large ship would like to know. Sound may come through the fog in strange ways. A horn may seem closer or farther than it is. Engines may be heard before anything is seen. The whole task becomes a slow assembly of clues. Modern navigation is powerful, but it does not excuse inattention. Radar can show a vessel. A IS can name it. Electronic charts can show routes and hazards. GPS can place the ship with remarkable accuracy. But people still have to use all of this correctly. They must keep watch, cross-check, slow down when needed, and act early. A radar target that is noticed too late is just a warning that arrived and was ignored. A screen full of information is not the same as understanding. A recent North Sea collision showed how visibility and watchkeeping can become deadly in modern waters. On March 10th, 2025, the container ship Solong collided with the anchored oil and chemical tanker Stena Immaculate, about 14 nautical miles northeast of Spurnhead, near the Humber estuary. The UK Marine Accident Investigation Branch published initial findings in April 2025 and reported that visibility in the area was patchy, varying between 0.25 and 2.0 nautical miles, and that neither vessel had a dedicated lookout on the bridge at the time. One crew member from Solong was missing and presumed dead. That incident was not in some distant age of wooden masts and lanterns. It happened with modern ships, modern equipment, and modern systems. The full investigation involved many factors, including navigation, watchkeeping, fatigue management, vessel condition, use of the anchorage area, and environmental conditions. It is a reminder that technology helps, but it does not replace seamanship. In restricted visibility, the old requirements still matter. Look out, listen, slow down, keep engines ready. Assume that what cannot be seen can still hurt you. Fog also changes the feeling of speed. In clear weather, a vessel's movement can be measured against the horizon, the coastline, waves, clouds, and passing marks. In fog, those references shrink. The ship may feel as though it is moving through a small, private bubble of visibility. But outside that bubble, everything continues at full scale. Other vessels keep moving. Currents keep setting. Banks remain where they are, or where the latest survey says they probably are. The coast is still there. The traffic lane is still busy. Fog does not make the sea smaller. It only makes the visible part of it smaller, which is much less comforting. Then there is darkness. Darkness at sea is different from darkness on land. On land, there are usually objects close by. Walls, roads, trees, lamps, windows, signs, the low glow of a town. Even in the countryside, there is ground underfoot and shapes against the sky. At sea, night can remove almost everything except motion and sound. The water becomes a dark, moving surface. The sky may blend into it. The horizon may vanish completely. A person can know intellectually that the sea is still there, the ship is still moving, and the world has not been erased. But the body prefers evidence, and darkness is not generous with evidence. Navigation lights help, but they are not the same as daylight. Ships show different lights according to their type, size, direction, and activity. A trained mariner can read these lights like a sentence. Red and green side lights, white masthead lights, stern lights, towing lights, fishing lights, anchor lights. The pattern tells you what kind of vessel may be there and which way it may be moving. It is an elegant system, but it requires attention, training, and clear enough air to see properly. In the North Sea, nightlights can be numerous. Ships show their lights. Offshore platforms glow. Wind farms show aviation and navigation marks. Buoys flash in coded patterns. Harbours shine in the distance. Towns along the coast create background light. In rain, mist, or fog, those lights can blur, scatter, or disappear. A vessel may be visible one moment, hidden the next. A light may look closer than it is. Two lights may line up and confuse the eye. Reflections on wet glass or spray-covered windows can add more uncertainty. The night sea is not simply dark. It is full of signals, and not all of them are easy to read. The loss of the horizon also affects balance and orientation. Human beings use visual information to help keep themselves steady. On a moving vessel, the horizon is one of the best references. When it disappears in darkness or fog, motion can feel more disorienting. A person on deck may feel the ship roll and pitch, but have fewer visual cues to prepare for it. This can increase fatigue and nausea, which in turn can reduce performance. Seasickness is often treated as a small comic inconvenience, but at sea it can be a serious problem. A sick, tired, disoriented crew is not at its best. The North Sea does not hand out easier conditions because someone has turned pale and gone quiet. For small vessels, night and fog can be especially dangerous because there is less height above the water. A low bridge or cockpit gives a shorter visual range. Lights may be harder to distinguish among waves and spray. Radar, if carried, may be smaller and less powerful. A yacht or fishing boat may be more affected by the sea state, making it harder to keep watch comfortably. On a dark, rough night, the simple act of moving around safely on deck becomes work. A wet rope, a low rail, a sudden roll, a wave over the bow, a loose object underfoot. None of these is dramatic in isolation. Together they can turn darkness into a hazard long before anything appears on the radar. Fishing vessels face particular risks because they often work rather than simply transit. Gear must be set, hauled, sorted, and secured. Lights from deck operations can ruin night vision. Work lights make the immediate area visible, but can make the darkness beyond seem even thicker. Crew members may be tired, wet, and focused on gear while the vessel moves in the waves and current. The North Sea fishing industry has always involved this kind of difficult practical labour. It is not only the storm that is dangerous, it is the dark hour when hands are cold, visibility is poor, equipment is under load, and the sea is not paused for anyone's convenience. Offshore energy work adds another layer. Oil and gas platforms and wind farms are lit and marked, but they also create areas where traffic patterns, service vessels, safety zones, and navigation decisions become more complex. At night, a wind farm can appear as a field of lights. In good visibility, those lights are managed and charted. In poor visibility, rain, or low cloud, they can be harder to interpret. Maintenance vessels may operate close to structures. Helicopters may be affected by cloud, fog, and darkness. The sea surface below may be rough, but the operation still depends on precise movement. Fog and darkness also change rescue. Search and rescue at sea is difficult even in daylight. In poor visibility, it becomes much harder. A person in the water is small. A life raft can be missed among waves. Sound may be misleading. Drift must be calculated. Search patterns must be planned. Helicopters, lifeboats, and nearby vessels use instruments, lights, thermal imaging, radar, and careful coordination. But poor visibility still slows and complicates the work. Time matters, especially in cold water. The North Sea's low temperatures mean that a rescue delayed by fog or darkness can quickly become more serious. The Solong and Stena Immaculate collision also showed this practical difficulty. Reports at the time noted that fog affected rescue and response conditions, while the MAIB's interim findings recorded patchy visibility in the area. Even when many resources respond quickly, poor visibility can make an already dangerous event harder to manage. There is a reason ships use sound signals in restricted visibility. A horn cutting through fog can feel old-fashioned, almost cinematic, but it remains part of collision avoidance. Sound gives warning when sight is reduced, yet sound at sea can be deceptive. Wind direction, temperature layers, rain, engine noise, and the shape of the coastline can affect how far and from where a signal seems to come. A foghorn is useful, not magical. It tells you something is there. It may not tell you enough. Radar too requires interpretation. It can show range and bearing. It can track movement. It can help calculate whether another vessel presents a collision risk. But radar images are affected by settings, sea clutter, rain clutter, target size, and operator skill. A small boat in rough seas may be harder to detect. A buoy may appear and disappear. A large vessel may be obvious, but obvious only helps if someone is watching and acting. The rules for restricted visibility emphasize safe speed and early action, because waiting until a target is visually confirmed may be too late. The human brain is also not perfect in low visibility. People can become overconfident in familiar waters. They can misread lights. They can trust one instrument too much. They can become fatigued during long watches. They can assume that another vessel has seen them. They can delay action because the situation is uncertain, and uncertainty is uncomfortable. At sea, hesitation can use up distance. The North Sea's traffic density and shallow hazards leave less room for that. Fatigue deserves its place here. Fog and darkness often arrive during watches when the body would rather be asleep. A night watch can be quiet, repetitive, and mentally demanding. The bridges dim, instruments glow, engines hum, the sea moves steadily. It is exactly the kind of environment where attention must remain sharp, while the body suggests, with some persistence, that resting would be lovely. In restricted visibility, fatigue is not just tiredness. It is reduced reaction time, poorer judgment, missed cues, and slower decisions. The sea does not need people to make huge errors. Sometimes, a small delay is enough. The North Sea's coastal areas add more visual complications. Approaching land at night can be surprisingly confusing. Shore lights may blend with navigation marks. A road or building light may look like a vessel light. A buoy may be lost against a background town. Rain on windows can distort everything. Fog can make lights bloom into halos. The closer a vessel gets to port, the more information appears, but not always in a helpful order. Harbours are safer than open sea in one sense, but approaches can be busy and constrained. A ship must move from open water into channels, traffic, pilots, tugs, buoys, speed limits, and depth restrictions. Doing this in poor visibility is a serious professional task. There is also the problem of scale. Large ships are deceptively slow-looking. From far away, a container ship or tanker may seem almost still, because it is so large and the horizon so wide. But at 15 or 16 knots, a ship is covering hundreds of meters every minute. In fog, where visibility may be less than a nautical mile, that matters. Two vessels closing each other can use up distance quickly. A large ship may need time to turn or stop. If action is delayed, the options narrow. The sea gives fewer second chances when the objects involved weigh tens of thousands of tons. For coastal walkers and beach users, fog and darkness create different risks. A tide that is manageable in daylight can become confusing when the landmarks disappear. On wide beaches or tidal flats, fog can make direction uncertain. Darkness can hide channels, soft mud, rocks, groins, and incoming water. A person may walk farther than intended and then struggle to find the route back. The North Sea's tidal coasts are not all steep cliffs and clear paths. Many are low, flat and change with the tide. In such places, visibility is safety. This is why local warnings matter. Beach signs, tide boards, harbour notices and coastguard advice may not have the romance of old sea tales, but they are built from hard experience. The coastline can look gentle. The danger may be that the world becomes unclear. Fog turns distance into guesswork. Darkness hides the return route. The tide removes the shortcut. A quiet evening walk can become a rescue call because the sea did exactly what the tide table said it would do, while the person on the sand did not have enough visibility to manage it. Darkness also makes cold feel worse. That may sound obvious, but it matters. A person in trouble at night is harder to find and may become colder faster because rescue takes longer. On deck, cold darkness reduces dexterity and alertness. In winter, long nights and low temperatures combine with wind, spray and fatigue. The North Sea in winter is not just dark for longer. It is a place where darkness has time to settle into every task. For centuries, lighthouses were built because the sea at night needed fixed points of certainty. Their beams marked headlands, reefs, harbour entrances and dangerous coasts. Lightships were stationed where towers could not be built. Buoys flashed and bells sounded. These aids to navigation were life-saving technologies, and many still matter today, even as satellite navigation has changed the work of finding position. A lighthouse is more than a pretty coastal landmark. It is a statement that the edge of land and sea has caused enough trouble to deserve a permanent warning. But even lights have limits in fog. A bright beam can be swallowed by dense air. A buoy's light may be hidden in waves. A shore light may not stand out against town lights. This is one reason navigation never relies on one thing alone. Position fixing, radar, depth, visual marks, sound, electronic charts, AIS, compass and judgment all support one another. In poor visibility, redundancy is not fussiness, it is survival. There is a quiet discipline to navigating when the horizon vanishes. The dramatic version of seamanship is a person wrestling with a wheel in a storm, rain flying sideways, face set with heroic concern. The real version may be calmer and more demanding, checking bearings, adjusting speed, plotting targets, listening to sound signals, calling traffic control, confirming the vessel's position, making small decisions early, and resisting the temptation to assume that everything is fine because nothing has yet appeared through the fog. Good seamanship often looks boring from the outside, which is unfair, because boring is frequently what keeps people alive. The North Sea rewards that kind of caution. It is a sea where poor visibility can meet strong tides, shallow banks, heavy traffic, and sudden weather. Fog alone is one hazard. Fog over a moving, crowded, shallow, cold sea is a system of hazards. Darkness alone is natural. Darkness with wind, spray, traffic, fatigue, and no horizon becomes a test. The danger is not simply that people cannot see. It is that seeing is connected to everything else they need to do. Think again of a vessel moving through a foggy North Sea morning. The world outside the bridge is pale and narrow. The radar turns steadily. The AIS list updates. The engine room hums. Somewhere nearby, a buoy gives a mark. Farther away, a ship sounds in the fog. The tide is setting across the route. A bank lies under the water ahead, safely avoided if the plane has followed. The crew has the tools to understand the situation, but every tool requires attention. Nothing about the scene is wild in a simple way. It is dangerous because it is demanding. Now let the same vessel pass into night. The fog thins, but the horizon does not return. Lights appear, some moving, some fixed, some clear, some blurred by rain. The sea is black under the bow. Spray catches the deck lights and flashes briefly white. The chart shows the route. The radar shows targets. A watchkeeper checks the bearing of a ship to starboard. Another light appears near the horizon, or where the horizon would be if the horizon had the manners to show up. Everything must be read carefully. The North Sea has not become invisible exactly. It has become a page written in smaller print. That is why fog, darkness, and the vanishing horizon belong in the story of deadly waters. They do not create the North Sea's strength, but they hide its details. They make distance uncertain, traffic harder to judge, banks easier to approach, rescue harder to carry out, and human error more likely. They turn a familiar route into a calculation. They make modern technology essential, but also reveal how much still depends on human watchfulness. And once visibility fades, the past seems closer too. It is easier to understand how earlier sailors lost ships on banks, missed harbour entrances, collided in crowded lanes, or waited for a light that never appeared through the murk. The North Sea's floor has wrecks because storms, shoals, currents, fog, darkness and human decisions have been meeting there for centuries. Many vessels crossed safely, many did not. Beneath the grey water lies the evidence of those bad nights, hard gales, missed marks, broken engines, and wrong turns, waiting in the next part of the story where ships, storms and wrecks turn the seabed into a record of what this sea has taken. The North Sea's wrecks are not gathered in one neat place like exhibits in a museum. They are scattered across banks, channels, approaches, fishing grounds, harbour mouths, battle areas and storm routes. Some are known and charted. Some are broken into shapes that only sonar reads clearly. Some are buried under sand, uncovered again after storms, then covered once more as if the seabed cannot decide whether to remember or forget. Others have become reefs, homes for fish and anemones, their metal softened by growth, their sharp human purpose slowly turned into habitat. A wreck is a very particular kind of record. It does not tell history in tidy sentences. It lies there with a broken bow, a missing funnel, a scattered cargo, a propeller half sunk in sediment, or a boiler standing on the seabed like an old iron heart. To look at a wreck is to see the exact place where a plan stopped working. A journey was underway, a crew had duties, a ship had a destination, then weather, war, fire, collision, grounding, mine, torpedo, fog, machinery failure, or one bad decision changed the story. The North Sea has had all of these. Its danger to shipping has never come from one simple cause. We have already met the shallow water, the strong tide, the shifting banks, the fast weather, the fog, the darkness and the cold. Now imagine all of those not as separate warnings, but as things happening to real vessels with people aboard. A fishing boat trying to return before a gale worsens. A ferry feeling for a harbour in poor visibility. A merchant ship in wartime crossing waters where submarines and mines have made the route deadly. A naval cruiser in battle, smoke drifting low over grey water. A tanker at anchor in fog while another ship approaches. The North Sea's graveyard was built from combinations. Some ships were lost because the sea itself was too much. Others were lost because people brought war into a place that was already dangerous. Many were lost because work had to continue. Fishing, trade, patrols, oil, gas, ferry crossings, supply runs, and rescue operations do not always wait for pleasant conditions. If humanity only went to sea when everything looked gentle, we would have a much shorter maritime history, and probably fewer dramatic paintings in seaside pubs. Fishing has always been one of the hardest parts of that story. A fishing boat is not simply travelling across the sea, it is working in it. It may slow down, turn, tow gear, haul nets, sort catch, and remain on grounds longer than a vessel simply passing through. Decks are wet. Gear is heavy. Lines can tighten suddenly. Crews work long hours, often in weather that people on land would describe as a good reason to stay indoors and reorganise a draw very slowly. In the North Sea, fishing has fed families and towns for generations, but it has also exposed them to storms with very little margin for error. One of the most remembered fishing disasters on the North Sea coast happened on October 14th, 1881, known in Eyemouth as Black Friday. After a spell of bad weather, the morning appeared calm enough for boats to leave, though the barometer was very low and some older fishermen warned against going. A sudden storm struck while the fleet was at sea, and 189 fishermen died, including 129 from Eyemouth itself. Many boats capsized or were wrecked along the coast. The disaster left families and whole communities changed in a single day. That story shows something very important about deadly seas. Disasters do not always begin with recklessness. They may begin with pressure. Bait is spoiling. Debts have to be paid. Families need food. Boats have already been kept in harbour. The morning looks calm. Someone checks the sky. Someone checks the glass. Someone says they should wait. Someone else says they cannot. And then the sea makes the decision final. It is easy, from a warm room many years later, to ask why they went out. It is harder to imagine the economic pressure of a fishing town, where staying ashore could mean hardship, and going out could mean death. The North Sea has often forced that kind of choice. The danger is not only physical, it is also tied to livelihood. People take risks at sea because the sea is where the work is. That has been true for fishermen, sailors, pilots, engineers, rig workers, lifeboat crews, and many others whose lives have been shaped by this water. Merchant ships added another layer to the North Sea's wreck story. For centuries, the sea has been a trade route between Britain, Scandinavia, the Low Countries, Germany, and beyond. Timber, coal, fish, grain, iron, textiles, oil, containers, passengers, machinery, and all the ordinary objects of life have crossed it. Every busy trade route produces wrecks because more ships mean more chances for storms, collisions, groundings, fires, navigational errors, and wartime attacks. A quiet sea with a little traffic may be dangerous to those few who cross it. A rough sea with heavy traffic becomes dangerous in a more crowded way. The North Sea is not just water between places, it is a working corridor. That matters because a ship in difficulty may not be alone, but it also may not have much room. Traffic lanes, anchorages, port approaches, fishing grounds, wind farms, offshore platforms, sandbanks, and restricted areas all create a sea where movement must be managed carefully. Modern systems reduce risk, but they also show how much risk there is to manage. A clear chart full of routes and symbols is useful, but it is also a reminder that the sea is not empty. War turned the North Sea into something even more dangerous. During the First World War, it became a major naval theatre between Britain and Germany. Fleets tried to control it, deny it, mine it, patrol it, and use it as a barrier and route. Submarines made merchant shipping far more vulnerable. Mines waited without needing weather, courage, or visibility. A mine is a particularly unpleasant invention because it turns empty-looking water into a threat that does not announce itself. It has no dramatic sail on the horizon. No engine noise, no warning shout. It just waits for contact, pressure, or proximity, depending on its type and period. UNESCO notes that the First World War left more than 10,000 shipwrecks on the seabed worldwide, including naval vessels, merchant ships, auxiliary vessels, and submarines, and that this underwater heritage remains vulnerable to corrosion, exploitation, and disturbance. The North Sea was one of the key places where that war at sea unfolded, and the wrecks from those years are not just debris. They are war graves, historical evidence, and reminders that the sea's danger has often been increased by human conflict. The Battle of Dogger Bank in January 1915 was one of the North Sea's major naval actions. British and German battle cruisers fought near Dogger Bank, the same broad, shallow feature we met earlier as a fishing ground and seabed hazard. The battle ended as a British victory, and the German Navy delayed further major action against the British fleet for more than a year. It is strange to think of a place like Dogger Bank in this layered way. To fish, it is food. To geologists, glacial history. To navigators, shallow ground. To ecologists, habitat. To naval history, a battlefield. The North Sea rarely lets one meaning stay alone for long. Then came Jutland, fought from May 31st to June 1st, 1916 near the Skagerrak, an arm of the North Sea off Denmark's Jutland Peninsula. It was the largest naval battle of the First World War, involving about 250 ships and around 100,000 men. The Imperial War Museums notes that about 6,000 British and 2,500 German sailors were killed, with Britain losing 14 ships and Germany losing 11, although Germany failed to break British control of the North Sea afterward. Those numbers are hard to hold in the mind. A ship is large, solid, engineered, named, crewed, painted, armed, supplied and commanded. It seems permanent while it floats, then battle changes that. At Jutland, huge ships could be hit, burn, explode or sink in minutes. Men worked inside steel compartments surrounded by noise, smoke, heat, darkness, machinery and water. The North Sea outside was cold and wide. Survival after a sinking was not simply a matter of escaping the ship. It meant being found in the water in battle conditions, with other ships manoeuvring and shells still falling. The water itself became the last enemy after the guns had already done their work. There is a temptation, when speaking of naval battles, to become too grand. Grand fleet, high seas fleet, battle cruisers, dreadnoughts, strategy, control of the sea. All of those words are accurate, but they can make the event sound cleaner than it was. The reality was human bodies inside metal, surrounded by fire and cold water. The National Archives notes that more than 6,000 British sailors lost their lives at Jutland, with particularly heavy losses linked to the unexpected sinking of HMS Invincible, HMS Queen Mary, and HMS Indefatigable. It was not a tidy contest on a map. It was confusion, blast, smoke, poor visibility, and men trying to survive inside machines built to fight other machines. The Second World War added more wrecks and more danger. The North Sea again became a region of mines, submarines, aircraft, convoys, patrols, and coastal defences. Ships were sunk not only by storms but by weapons. The seabed accumulated metal from war as well as commerce. Some wrecks became known, others became hazards. Some still carry the sensitivity of graves. A wreck from war is not just an object. It may be the resting place of a crew. That is why underwater cultural heritage is handled with such care, or should be. The sea may cover a wreck, but it does not remove its meaning. Even away from battle, storms kept making their own additions to the seabed. A storm can drive a ship onto a bank, tear a vessel apart near a harbour entrance, or make rescue nearly impossible. It can also expose wrecks that had been hidden under sand for decades or centuries. This is one of the strange habits of shallow sandy waters. A wreck may sleep unseen, protected by burial, then winter storms rip away sediment and reveal timber, iron or cargo again. Archaeologists may have only a short time to study it before the sea damages it or buries it once more. The seabed is not a locked archive. It is more like a filing cabinet being shaken by weather. The UK Hydrographic Office maintains data on navigationally significant wrecks in UK waters, and the European Marine Observation and Data Network reported in 2025 that a UK HO maintained global wreck dataset available through EMODInet contains more than 94,000 charted and uncharted wrecks worldwide. That figure is not a North Sea count by itself, but it gives a sense of how much human history lies beneath the water globally, and how important wreck data remains for modern navigation. Wrecks are memories, but they are also physical hazards. A mast, hull, or scattered structure may reduce depth, catch fishing gear, complicate anchoring, or affect seabed work. In the North Sea, wrecks can also become part of the working environment. Fishermen know areas where gear might snag. Survey vessels map obstructions. Wind farm developers scan the seabed before building. Pipeline and cable routes must avoid or account for wrecks, unexploded ordnance, and archaeological sites. A wreck is not always left alone because everyone has forgotten it. Sometimes it is carefully avoided because people remember enough to keep their distance. The North Sea's modern offshore industry has its own disasters too. The most devastating is Piper Alpha. On July 6, 1988, the Piper Alpha oil production platform in the North Sea exploded and was destroyed. Britannica records that 167 people were killed, making it the world's deadliest offshore oil disaster. This was not a shipwreck in the old sense of a vessel driven onto rocks or sunk by a storm, but it belongs to the same wider truth. The North Sea is not only a place where ships pass, it is a place where people live and work on exposed structures surrounded by cold water, weather, distance, machinery, fuel, and risk. Piper Alpha shows that danger offshore can come from systems as much as from waves. A platform may stand above the water, but it still depends on maintenance, communication, emergency planning, design, training, and timing. When those fail, the sea becomes part of the emergency. Escape routes may lead toward lifeboats, rafts, rescue vessels, helicopters, or, in the worst circumstances, into the water itself. The North Sea beneath a burning platform is not a soft landing. It is cold, dark, and far from shore. A disaster offshore is never only the moment of explosion or fire, it is also evacuation, rescue, survival, and the fight against time. Collisions remain another modern threat. Radar, AIS, traffic systems, better charts, and strict rules have greatly improved safety, but ships still meet in poor visibility, at night, near anchorages, and in busy routes. Large vessels take time to turn and stop. Human fatigue, equipment problems, bad assumptions, and restricted visibility can still create accidents. In March 2025, the container ship Solong collided with the anchored tanker Stena Immaculate off the Humber area in the North Sea. The UK Marine Accident Investigation Branch reported patchy visibility and stated in its interim findings that neither vessel had a dedicated lookout on the bridge at the time. One Solong crew member was missing and presumed dead. That modern example matters because it prevents the story from becoming too historical. It would be comforting to think the graveyard beneath the waves belongs mainly to the age of sail, steam, coal smoke, and hand-drawn charts. But the North Sea still demands attention from modern crews using modern equipment. The causes have changed in some ways, but the need for watchfulness has not. Fog is still fog. A heavy ship is still heavy. Cold water is still cold. A missed lookout is still dangerous. There is also a quieter form of danger in old wrecks themselves. Metal corrodes. Fuel can remain trapped. Ammunition may still be hazardous. Fishing gear can snag. Divers can be tempted into unstable structures. Archaeological sites can be damaged by trawling, anchoring, looting, or construction if they are not properly identified and protected. UNESCO's underwater heritage work stresses that submerged sites are valuable records of human history and that they are threatened by exploitation, pollution, climate change, and other human impacts. So the graveyard beneath the North Sea is not simply a collection of past losses, it is an ongoing responsibility. Strangely, wrecks can also become places of life. Once a ship settles on the seabed, its hard surfaces may provide shelter and attachment points for marine organisms. Fish gather, crabs move through gaps, anemones and sponges grow where paint and steel once served only human purposes. This does not erase the tragedy of the sinking, but it adds another layer. The North Sea does this often. It takes something human, breaks it, buries it, rusts it, and then turns parts of it into habitat. The result is not neat comfort, but it is a reminder that the sea is never only destructive, it also reuses. Still, for those who lost family members, a wreck is not merely habitat or heritage. It is the place where someone did not come home. Fishing towns, naval families, merchant crews, offshore workers, lifeboat communities and coastal villages carry memories that are more personal than any chart. A name on a memorial may correspond to a location offshore, a storm date, a vessel, a last sighting, a telegram, or a story told in a family for generations. The North Sea's deadliness is measured not only in wreck counts, but in empty chairs, widows, children, and communities altered by one day of weather or war. This is why maritime memorials along the North Sea coast often feel so grounded. They are not abstract monuments to adventure. They remember work, men who went fishing, crews who sailed, lifeboatmen who launched when others were in trouble, sailors who served in war, workers who flew offshore and did not return. These memorials stand on land, but they face the water because the story is out there. A graveyard beneath the waves is not always visible, and perhaps that is why it holds such power. On land, a battlefield may have fields, markers, preserved trenches, cemeteries, museums, and paths. At sea, the surface closes. The waves keep moving. Ships pass over places where other ships ended. Ferries cross routes above wrecks. Fishing boats work near old losses. Wind turbines rise in waters that have seen storms, battles, and sinkings. The sea does not pause to point downward and explain. It carries on, which is both ordinary and unsettling. To understand the North Sea as one of the world's deadly waters, we need this long memory. The danger is not only what might happen tomorrow, it is what has happened again and again under different names: storm, shoal, collision, mine, torpedo, fire, fog, surge, engine failure, human error, bad luck, economic pressure, war. Each event leaves a trace, sometimes a wreck, sometimes a regulation, sometimes a changed design, sometimes a warning passed down to younger crews. Disasters teach, but the tuition is dreadful. Modern safety at sea is built from those lessons. Better forecasts, lifeboats, radios, radar, GPS, AIS, survival suits, traffic separation schemes, offshore safety rules, hydrographic surveys, and emergency procedures did not appear because the sea became easier. They appeared because people learned, often painfully, what happened without them. Every improvement has a history behind it. Somewhere in the background there is usually a storm, a wreck, a collision, a fire, or a rescue that did not come fast enough. And even with all this, the North Sea remains a working sea. Ships still cross, fishing boats still head out, ferries still run, platforms still operate, wind farms grow across the horizon, survey vessels scan the bottom, lifeboat crews train, coastguards monitor, pilots board ships in poor weather, engineers climb turbines. People continue because the sea is useful, necessary, and deeply woven into modern life. Picture it now from below. Not the surface this time, but the seabed. Sand moves in low ripples. A wreck lies partly buried, its outline broken but still recognisable. Nearby, a trawl scar crosses the sediment. Far above, a vessel's engines pass as a low vibration through the water. Fish move through rusted openings. A lost anchor chain disappears into the sand. A crab picks its careful way across a plate of steel that once belonged to a ship with a name, a crew, and a destination. Above that quiet place, the weather is already changing again. The tide is turning. A ship is entering a traffic lane. A fishing boat is watching the forecast. Farther south, low coasts and estuaries wait behind their defences. Because the North Sea's danger has never stopped at the waterline. Sometimes the sea takes ships, sometimes it comes for the land itself, rising under wind and pressure, pushing into towns and fields, and reminding the coast that the boundary between land and water is not as fixed as it likes to believe. Sometimes the North Sea does not wait for people to come to it. Sometimes it comes inland. That may be the most frightening thing about a storm surge. A storm at sea is dangerous enough when ships are out in the weather, when crews are watching the wind, waves, engines, charts, and each other. But a surge changes the direction of the danger. It pushes the sea across the boundary that people thought was settled. It brings salt water into streets, fields, houses, railway lines, churches, farms, and bedrooms. It turns coastlines into openings. It makes the sea not only something to cross, but something that can arrive at the door. A storm surge is a rise in sea level caused by a storm. Strong winds push seawater toward the coast, and low air pressure also lets the sea surface rise slightly, because there is less weight from the atmosphere pressing down on the water. The Met Office explains that the timing matters greatly in places with large tides, because a surge arriving at the same time as a high tide can create flooding, while the same surge arriving a few hours earlier or later may be far less destructive. That is a small timing difference with enormous consequences, which is exactly the sort of detail the North Sea has always enjoyed making important. The North Sea is especially suited to dangerous surges because of its shape. It is shallow over large areas, and it narrows toward the south between Britain and the European mainland. When strong winds push water down the basin, especially from the north or northwest, that water can be driven toward the low coasts of eastern England, the Netherlands, Belgium, Germany, and Denmark. It cannot simply vanish, it piles up. If it piles up during a high spring tide, the result can be water levels far above normal. The sea does not need to leap over the land in one dramatic wall. It may rise, press, overtop, seep, break, and keep coming. The most famous example is the North Sea flood of 1953. On the night of January 31st into February 1st, a severe storm over the North Sea produced a storm surge that struck low-lying coasts around the Netherlands, eastern England, Belgium, and Scotland. Britannica describes it as the worst storm surge on record for the North Sea. In the Netherlands, about 400,000 acres were flooded, at least 1,800 people died, and the damage was widespread. In eastern England, up to 180,000 acres were flooded, around 300 lives were lost, and about 24,000 homes were damaged. At least 200 more people died at sea, including 133 passengers aboard the ferry Princess Victoria. Those numbers are difficult to imagine properly, because numbers can become too neat. A flooded acre sounds like a measurement. A damaged home sounds like a category. A death toll sounds like a line in a history book. But each number was a place where the water entered. A farm where animals drowned, a house where furniture floated, a family waiting in the dark, a road cut off, a person climbing upward because the lower floor had become sea, a village listening to wind, water, and breaking timber. The 1953 surge did not happen because people had never seen storms before. It happened because a particular combination arrived together: a powerful North Sea storm, high winds pushing water southward, low pressure, a high spring tide, vulnerable low-lying land, and warning systems that were not yet good enough to reach people in time. The Met Office notes that the 1953 surge happened at the same time as a high spring tide, and that although the storm and surge were forecast, public warning systems were not effective enough at the time. This is an important point. Disasters are often made from ordinary parts arranged in the worst possible order. Wind is ordinary. Tide is ordinary. Low pressure is ordinary. Low land is ordinary. A weak warning system is ordinary until the night it is needed. Then all of it comes together, and the ordinary becomes catastrophic. In the Netherlands, the flood became a national trauma. Rijkswaterstaat describes the 1953 flood disaster as the largest Dutch natural disaster of the 20th century. A heavy northwesterly storm combined with a spring tide, large parts of the country flooded. 1,836 people died. Tens of thousands of animals were lost and homes were destroyed. The Dutch had lived with water for centuries, but this event made clear that older defences and older assumptions were not enough. The images from the Dutch disaster are still stark. Broken dikes, houses standing in water, people rescued by boat from upper floors and roofs, livestock dead in flooded fields, salt water spread across farmland. The sea had entered a country that already knew the sea very well, which must have made the shock even harder. There is a special kind of fear in being attacked by something familiar. The Netherlands had been managing water for generations, draining land, building dikes, pumping polders, and organising life below sea level. Then, in one night, the North Sea showed how much work was still needed. In eastern England, the flood-hit places along the coast from Yorkshire down through Lincolnshire, Norfolk, Suffolk, Essex, and the Thames estuary. Seawalls, dunes and defences were overtopped or broken. The Met Office records that the surge measured nearly 3 metres in Norfolk, and even more in the Netherlands, with around 160,000 hectares flooded in eastern England, and 307 deaths there. It also notes the pounding of coastal defences from Yorkshire to the Thames estuary, with sand scoured from beaches, timber-piled dunes breached, concrete seawalls crumbling, and promenades damaged at places such as Mablethorpe and Sutton-on-Sea. This is what a storm surge does to a coastline. It tests everything. It tests earth banks, concrete walls, dunes, doors, roads, drainage, pumps, warning systems, and human confidence. A calm seawall can look solid for years, even decades. People walk beside it. Children sit on it with chips. Couples lean against it in windy weather. Then the wrong surge arrives, and the wall is no longer scenery. It is the last line between daily life and the North Sea. The Thames estuary was one of the areas that learned this lesson deeply. The 1953 flood reached parts of East London and exposed how vulnerable the capital could be to a surge coming in from the North Sea and up the Thames. London had already flooded before, including severe Thames flooding in earlier centuries, but the modern city had grown into a place full of underground railways, power systems, roads, hospitals, homes, offices, and national institutions. Flooding there would not be a local inconvenience. It would be a national emergency wearing wet shoes. The Thames Barrier is one of the direct results of that awareness. It became operational in 1982 and was officially opened in 1984. The Environment Agency describes it as one of the largest movable flood barriers in the world. It spans 520 metres across the River Thames near Woolwich and protects 125 square kilometres of central London from flooding caused by tidal surges. Its 10 steel gates can be raised across the river, and each main gate weighs 3,300 tonnes. That is a very large way of saying, please stay out, sea. And yet even that enormous structure works with timing. The Environment Agency forecasts dangerous conditions using information from satellites, oil rigs, weather ships, coastal stations and computer models, and it can forecast dangerous conditions up to 36 hours in advance. The barrier closes after low tide, or about 4 hours before the peak of an incoming tide surge reaches it, then remains closed over high water until the downstream level falls again. This is not a wall that simply sits there looking stern. It is operated according to the tide, river flow, surge forecasts and the needs of a living city. There is something quietly impressive about that. A 19th century flood defence might be a fixed embankment. The Thames Barrier is more like a mechanical decision. It waits, watches, closes, holds, opens, and lets the river breathe again. It is not romantic in the old lighthouse sense, but it is one of the great pieces of North Sea survival engineering. Also, each gate weighing thousands of tons does make the average garden gate seem frankly underachieving. The Netherlands responded even more dramatically with the Delta Works. Britannica describes the Delta Works as a giant flood control project in the southwestern Netherlands, given urgent priority after the catastrophic flood of February 1st, 1953. It included dams and barriers that shortened the vulnerable coastline and reduced exposure to the North Sea. Construction began soon after the disaster and major works were completed in the later 20th century. Rijkswaterstaat describes the Delta Works as the largest Dutch defence system against high water from the sea. Built to protect the Netherlands after the 1953 disaster, the system includes 5 storm surge barriers, 2 locks, and 6 dams, and it exists because large parts of the country lie below sea level and millions of people and much of the economy depend on flood protection. This is the North Sea's influence written in concrete, steel, gates, sluices, dikes, locks, and operating rooms. The coastline did not simply repair itself after 1953. People changed it. They shortened it, strengthened it, closed parts of it, recalculated safety standards, built barriers that could remain open in normal conditions and close during storms. The Dutch did not defeat the sea, because no coastal country ever really does. They made a more careful agreement with it. The Oosterschelde Kering, or Eastern Scheldt storm surge barrier, is one of the clearest examples. Britannica explains that unlike some earlier Deltaworks dams, it has adjustable gates that normally allow tidal seawater to move in and out, helping protect fish, birds, and local fisheries. During a severe storm, the gates can be dropped to keep out high tides and storm surges. This is a more flexible kind of defence, one that tries not only to hold back the sea, but to keep part of the tidal ecosystem alive. That is a complicated balance. Close everything completely, and you may protect the land but alter the water, ecology, fisheries, and local life. Leave everything open, and the sea keeps its old roots inland. The modern coast is full of such decisions. Safety, environment, economy, history, and engineering all have to sit at the same table, usually with maps, models, and someone saying, "This will be expensive," which is one of the oldest phrases in civil engineering. Storm surges changed Germany too. In February 1962, Hamburg suffered a devastating North Sea storm surge. The city of Hamburg records that on February 16th, 1962, a powerful flood wave came from the North Sea up the Elbe toward the city, destroyed dikes, and killed 315 people in Hamburg. Thousands lost their possessions or were made homeless. Hamburg is not right on the open North Sea coast. It sits far inland on the River Elbe. That is what makes the 1962 event such a strong reminder of how storm surges can travel. Water driven into an estuary does not stop at the seaside just because the postcards do. It can move upriver, raising levels far from the open coast. The Hamburg Port Authority describes the disaster as the result of a chain of circumstances, including the strength of wind over the North Sea, water pressure in the Elbe estuary, and an unfavourable tide window. It also notes that modern Hamburg now relies on storm surge warning, dikes, barrages, locks, and mobile gates for flood protection. This matters because it shows that a storm surge is not only a coastal wave problem, it is a water level problem. Estuaries are funnels. Rivers are roots. Low land can lie far from open surf and still be vulnerable. A person in an inland district may not think of themselves as living beside the North Sea, but the water may still have a route to them if wind, tide, and geography align badly enough. After these disasters, the coastlines around the North Sea became more engineered, more monitored, and more alert. Dikes were strengthened, barriers were built, warning systems improved, forecasting became more advanced, emergency planning changed. Governments learned that flood defence is not just a line of concrete, it is a system involving weather prediction, tide gauges, communication, evacuation planning, maintenance, land use decisions, and public trust. Public trust is not a small thing. A warning only matters if it reaches people and people know what to do with it. In 1953, many people were asleep when water came. Communication systems failed or were too slow. Today, warnings can travel faster, but the challenge is different. People may receive too many alerts and ignore them. They may misunderstand the seriousness of coastal flooding. They may assume defences will always hold because they have held before. That is a very human assumption, and the North Sea has spent centuries being rude to human assumptions. The modern coast is safer than it was, but it is not risk-free. The Thames Barrier had been closed 221 times for flood defence purposes since becoming operational, according to Environment Agency figures correct to November 17th, 2025. Of those closures, 119 were to protect against tidal flooding and 102 were to protect against combined tidal and river flooding. That number is not just a statistic. It means the barrier has repeatedly been used for the exact reason it was built. London has not had to learn the old lesson again in the old way, and that is what good infrastructure often does. It prevents disasters so quietly that people begin to forget the disaster was possible. A successful flood defence can become almost invisible in daily life. People cross the river, ride trains, buy coffee, complain about the weather, and rarely think about the gates waiting downstream. Prevention is not dramatic, which is why it is so easy to undervalue until water is already on the stairs. The Netherlands also continues to invest in stronger water defences. Rijkswaterstaat says the country still invests every year in stronger barriers, and that the Water Management Centre Netherlands monitors water safety 24 hours a day, 365 days a year. It also states that 60% of the Netherlands could flood in a major event, which makes flood protection a constant national concern rather than a finished historical project. That is one of the clearest differences between remembering a disaster and truly learning from it. Remembering puts flowers by a monument. Learning keeps funding maintenance, checking dikes, updating forecasts, testing gates, training emergency teams, and arguing over future sea level scenarios in rooms where the coffee is probably not as good as the subject deserves. Climate change adds another problem. Rising sea levels mean that future storm surges may start from a higher baseline. A surge of the same size becomes more dangerous if the normal sea level is higher when it arrives. This does not mean every storm will automatically become a 1953-style disaster, and it does not mean the North Sea is about to walk casually into every coastal town with a suitcase. But it does mean flood defences, planning and warning systems cannot be based only on the past. The sea level of the future will not politely remain at the level used in old calculations. This is why long-term plans matter. The Environment Agency's Thames Estuary 2100 plan sets out how flood risk in the Thames Estuary will be managed to the end of the century and beyond, with short, medium and long-term actions. That is the kind of planning a storm surge demands. Not a quick patch after a bad night, but a living plan that changes as the water, land, science and city change. Storm surges also change the emotional coastline. After 1953, people did not look at the sea in quite the same way. A seawall was not just a path. A dike was not just a line of grass. A tide table was not just useful for fishing. A warning siren, radio broadcast or flood alert was not background noise. The water had shown what it could do, and that memory stayed in families, towns and national policy. You can imagine a quiet lowland village before the flood. Fields flat under a winter sky, houses low and close to the ground, ditches, lanes, church towers, farm buildings, and the smell of wet earth. The sea might be out of sight behind a dike, but it is still present in the way the land is drained, the way roads are built, the way people speak about weather. Then the surge comes at night. The dike breaks. Water moves where it has no business being. The next morning the familiar place has become a wide, cold, brown-grey surface with roofs, trees, poles and debris sticking out of it. That is not only damage, it is the world being rearranged. And after the water leaves it is not over. Salt remains in soil. Buildings must be cleaned or demolished. Animals are gone. Roads are broken. Families search for missing people. Bodies must be recovered. Insurance, aid, rebuilding, engineering surveys, political inquiries and grief all begin. A flood is not a single event. It is a long aftermath with mud on its boots. The North Sea storm surges changed coasts physically, but also changed how countries think. The Dutch delta works, the Thames Barrier, strengthened dikes in Germany, Warning systems, coastal monitoring and flood planning all belong to the legacy of water that crossed the line. These are not separate from the sea's deadly reputation. They are proof of it. A harmless sea does not require movable gates weighing thousands of tons. A mild neighbour does not lead nations to redesign their coastlines. Still, it is important not to turn the North Sea into a villain. The sea is not plotting against anyone. A storm surge is physics, wind stress, pressure, tide, basin shape, depth, coastline, and timing. The tragedy comes when those physical facts meet human settlement, weak defences, poor warnings, bad luck, or a future for which the past has not prepared us. The North Sea is deadly because it is powerful and close to people. It is not remote enough to ignore. It is not gentle enough to trust blindly. So when we think of the great storm surges, we should not imagine them only as historical disasters. We should imagine them as teachers, although rather severe ones. They taught that low land must be defended. They taught that warnings must reach people quickly. They taught that dikes need maintenance, not admiration. They taught that estuaries can carry the sea far inland. They taught that a coastline is a system, not a line. They taught that the North Sea does not need to sink ships in order to be deadly. Sometimes it only needs the right wind, the right tide, and a sleeping coast. Now the grey water sits again beyond the defences. Dikes run along low land. Barriers wait in estuaries. Tide gauges measure the rise and fall. Forecast models calculate pressure, wind, and surge. Engineers inspect gates. Coastguards issue warnings. On calm days, people walk beside the sea with dogs, children, bicycles, ice cream, and the ordinary confidence of a normal afternoon. That confidence is allowed. It is part of living by the coast. But beneath it there is also memory, built into concrete and steel. The storm surges changed the coast because they forced people to accept that the North Sea is not only a waterway, workplace, fishing ground, battlefield, or horizon. It is a force that can enter the land when conditions align. And once that is understood, the final question becomes clearer. Why does the North Sea still demand respect today, in an age of satellites, barriers, radar, forecasts, modern ships, and carefully monitored coastlines? The answer is that every defence, every vessel, every forecast, and every plan is still working, with a sea that remains shallow, cold, crowded, stormy, tidal, and capable of surprise. And that is why the North Sea still demands respect, not fear in the simple sense. Not the kind of fear that turns the sea into a monster or makes every grey wave seem like a threat. Respect is quieter than fear. It is more useful too. Fear may freeze a person in place, but respect checks the forecast, reads the tide table, listens to warnings, maintains the engine, wears the life jacket, inspects the seawall, and does not assume that a familiar stretch of water has become harmless just because it has been familiar for a long time. The North Sea is not deadly because it is always wild. That would almost make it easier to understand. If it were permanently raging, if every day brought towering waves and black skies, people would treat it with constant caution. But the North Sea can be calm. It can look flat from a harbour wall. It can shine under weak winter sunlight. It can carry ferries, fishing boats, container ships, tankers, supply vessels, and wind farm crews through ordinary working days. It can sit beside beaches where people walk dogs, eat chips, take photographs, and say things like, "It's actually quite nice out," which around the North Sea is sometimes less a weather report and more an act of optimism. That calm is real, but it is not the whole truth. The North Sea remains dangerous because its hazards do not go away when the surface looks manageable. The shallow seabed is still there. The tide is still running. The sandbanks still shift. The weather is still forming beyond the horizon. The fog can still come in. The cold water still drains strength. The traffic lanes are still busy. The low coasts still need their defences. The wrecks are still below, and the memory of the great surges is still built into the barriers and dikes. This sea has many moving parts, and none of them are required to look dramatic before they matter. It is one of the most heavily used seas in Europe and globally, with shipping, fishing, aggregate extraction, energy production, offshore wind, oil and gas, ports, aquaculture, shipbuilding, cruise tourism, and coastal protection all sharing the same basin. The European Maritime Spatial Planning Platform notes that 3 of the world's largest ports, Rotterdam, Antwerp and Hamburg, are in the North Sea basin, and that shipping and port activity create intensive maritime traffic there. That is a great deal to ask of one shallow sea. A lonely ocean can be dangerous because help is far away. The North Sea is dangerous in another way. Help may be closer, but so is everything else. Other ships, anchorages, harbour approaches, pipelines, cables, wind farms, fishing grounds, platforms, buoys, banks, restricted areas, conservation zones, dredged channels, traffic separation schemes. A ship crossing the North Sea is not simply moving across an empty blue space. It is moving through a working landscape where the water column, the surface, the seabed, and the air above are all being used. That crowdedness is modern, but the sea beneath it is old. It has not become deeper just because ships have become larger. It has not become warmer because engines are better. It has not stopped making steep waves because forecasts are more accurate. A satellite can see the clouds, but it cannot make a gale gentler. Radar can show a target, but it cannot make 2 ships pass safely unless people act correctly. A storm barrier can close against a surge, but it still needs maintenance, timing, and planning. Technology is a conversation with danger, not the end of danger. The collision between Solong and Stena Immaculate in March 2025 is a modern reminder of this. The UK Marine Accident Investigation Branch reported that the container ship Solong and the oil and chemical tanker Stena Immaculate collided 14 nautical miles northeast of the Humber estuary, causing 1 fatality. The incident happened in one of the North Sea's busy approaches, not in some forgotten corner of the world. That does not mean every crossing is waiting to become a disaster. It means the North Sea still depends on attention. The rules that sound old-fashioned, keeping a proper lookout, proceeding at a safe speed, respecting restricted visibility, are not old because they are outdated. They are old because they are still true. The sea has a way of making very modern people relearn very basic things. The same is true offshore. The North Sea has been one of the world's major offshore energy regions for decades. Oil and gas activity created a large network of platforms, pipelines, supply routes, helicopter flights, maintenance vessels and safety systems. OSPA notes that oil and gas development has produced a large number of offshore installations in the North Sea, and that more than 1,948 offshore installations are operational across the wider OSPAR maritime area, with many approaching decommissioning as the province matures. Every structure offshore changes the way the sea is used. A platform is a workplace standing in water. A pipeline is a route across the seabed. A cable is a hidden line that must be protected. A wind farm is a field of tall machines in a place where vessels, birds, currents and weather already move. None of this is wrong by itself. These systems provide energy, jobs, transport and infrastructure. But they also add complexity, and complexity is one of the North Sea's quietest dangers. Offshore oil and gas also brings environmental risk. OSPA's 2023 assessment says environmental impacts can occur across exploration, production and decommissioning, including produced water, oil, chemicals, drilling muds and cuttings, physical impacts from installations and pipelines, noise, light and atmospheric emissions. It also says pressures from offshore oil and gas activities are greatest in the North Sea within the OSPAR regions. So respect here does not only mean keeping ships afloat, it means caring for a working sea without pretending that work has no footprint. It means understanding that a spill, a collision, a cable strike, a platform incident, or poor decommissioning decision does not happen in an empty place. It happens in a living sea with fish, birds, mammals, sediments, fisheries, coastal communities, and countries that depend on the water being safe enough to use and healthy enough to continue supporting life. The North Sea is also changing. Offshore wind is growing. Older oil and gas structures are being removed or repurposed. Shipping continues, coastal populations remain, and climate change is raising the stakes. The sea's future danger will not be exactly the same as its past danger. That is a simple sentence, but it is not a small one. The old hazards remain, while new pressures are added. Sea level rise is one of the clearest examples. The European Environment Agency says that rising mean sea levels are the main driver of observed and projected increases in extreme sea levels along European coastlines, and that coastal floods are a growing threat to buildings, energy and transport infrastructure, water supplies, ecosystems and human lives. This matters around the North Sea because so much of its coast is low, populated, engineered and economically important. A storm surge arriving in the future may ride on a higher baseline than a surge in the past. That means flood defences need to be managed not only for what has happened before, but for what is becoming more likely. The Environment Agency's Thames Estuary 2100 guidance says sea levels are rising. Tidal flooding from the Thames is a real future risk, and tides will get higher during the 21st century because of rising sea levels and bigger, more frequent storms in the North Sea. There is something uncomfortable about that. The great storm surges we already discussed are not just stories from history. They are warnings about a system that still exists. The difference now is that we know more, measure more, model more, and build better defences. But we also have more people, more infrastructure, more value, and more dependence on the coast. A flood today can affect homes, power systems, underground transport, data cables, hospitals, ports, refineries, roads, railways, and supply chains. A modern coastline is not simpler than an old one. It is more connected, which means disruption travels farther. That is why respect for the North Sea cannot be limited to sailors. It belongs to planners, engineers, ferry operators, fishermen, coast guards, climate scientists, harbour authorities, offshore technicians, environmental managers, and people who live behind dikes and seawalls. It belongs to anyone who benefits from the ports, energy, fish, trade, and transport that this sea provides, which is to say, quite possibly people who have never even seen it. There is a strange thing about modern life. Much of it crosses the sea without announcing itself. A parcel arrives. Fuel reaches a terminal. Food appears in a shop. Electricity travels through cables. Data moves unseen. A ferry docks. A turbine turns offshore. A container is unloaded. We enjoy the result on land and rarely think about the water in between. The North Sea is part of that hidden machinery. It carries the background work of everyday life. And because it does that work so constantly, it can disappear from attention. But the sea has not disappeared. It is still there, doing what it has always done, moving, mixing, rising, falling, freezing hands, shifting sand, testing hulls, feeding birds, carrying ships, wearing away cliffs, receiving rivers, lifting fog, building waves, holding wrecks. It is not waiting politely outside human systems, it is inside them. The North Sea still demands respect because it is not one danger, but a collection of ordinary dangers that meet. A shallow seabed is manageable. Wind is manageable, tide is manageable, fog is manageable, traffic is manageable, cold is manageable, a sandbank is manageable, a storm surge risk is manageable. But when several of these arrive together, the margin gets smaller. A vessel might handle strong wind in deep open water. It might handle shallow water in calm weather. It might handle fog in light traffic. It might handle heavy traffic in good visibility. It might handle a strong tide with enough room. The North Sea's skill is in refusing to keep these problems separate. It gives the crew wind against tide over shallow ground in poor visibility near a busy approach, and then quietly asks whether everyone has read the procedure properly. This is also why experience matters so much. Local knowledge is not superstition. It is accumulated contact with a complicated place. Fishermen know where the water stands up over a bank. Pilots know how a ship handles in a channel with cross-current. Lifeboat crews know which areas become rough in certain winds. Harbour masters know when a tide window is closing. Coastal residents know which storms make them look twice at the seawall. Scientists know what the gauges show. Engineers know which defences need work. Each kind of knowledge sees a different piece of the sea. Respect means listening to all of it. It also means accepting that safety is never finished. A chart is updated, a buoy is moved. A warning system is tested, a dike is inspected, a barrier is maintained, a crew is trained, a report is written after an accident, a regulation is reviewed, a forecast model improves, a harbour plan changes, a wind farm is marked, a cable route is surveyed. These things may sound administrative, and perhaps they are, but administration, when it is done well around a dangerous sea, is one of the quieter forms of survival. There is a calm dignity in that. The North Sea has produced dramatic stories, but most safety is not dramatic. It is paperwork, maintenance, checking, training, monitoring, and someone deciding not to go yet. It is a captain reducing speed in fog, a beach walker turning back before the tide cuts off the route, a port delaying a movement, an engineer replacing a worn part before it fails, a flood authority closing a barrier before the water rises, a lifeboat crew practicing on a bad day so that a worse day is not the first time. None of this makes a thrilling painting. It does, however, keep people alive. The North Sea's deadliness also teaches a larger lesson about familiarity. Many of the most dangerous things in life are not the rare things we know to fear, but the familiar things we begin to underestimate. A road we drive every day, a machine we use at work, a coastline we grew up beside, a tide that has always come in and gone out, a sea we can name on a map. The North Sea is familiar to millions, but familiarity is not permission to stop paying attention. And yet, respect should not strip away affection. People love this sea, not always in a soft postcard way. Sometimes the affection is grumbling, practical and wind-battered. Fishermen may curse it and still return. Coastal walkers may complain about the cold and still miss it when inland. Sailors may respect its roughness and still feel at home there. People who live by the North Sea learn its colours, its smells, its sudden changes, its gulls, its flat light, its long beaches, its harbours, its ferries, its oil rigs, its turbines, its foghorns, and its strange ability to make rain feel personal. That affection matters. A sea that is only feared becomes distant. A sea that is only used becomes exploited. A sea that is respected can be lived with more wisely. The North Sea needs that wiser relationship because it is too important to ignore and too dangerous to treat casually. So, after all this, why is the North Sea one of the world's deadliest waters? Because it is shallow enough to make waves steep. Because its weather can change quickly. Because its tides and currents are strong. Because its sandbanks and shoals move. Because fog and darkness can hide danger in a crowded sea. Because ships, storms, war and work have filled its seabed with wrecks. Because storm surges can push the sea onto low land. Because modern industry has made it more useful and more complex. Because cold water shortens the time people have when something goes wrong. Because it sits beside some of Europe's busiest coasts and busiest ports. Because it is not remote, it is close, familiar, and constantly used. And because danger that is close and familiar is sometimes the easiest to forget. Now, imagine one final view of it. Not during a disaster, not in a gale, just an ordinary North Sea evening. The sky is low but clearing. A ferry light moves in the distance. Farther out, a ship follows its lane. A wind farm stands on the horizon, its turbines turning slowly. Somewhere below, the tide runs over sand. A wreck rests under a layer of sediment. A buoy flashes its pattern. On land, behind the seawall, people are making dinner, closing curtains, walking dogs, and checking tomorrow's weather without thinking too much about the old water beyond the shore. That ordinary evening is the point. The North Sea does not need to be dramatic to be powerful. Its seriousness lives inside ordinary motion. Tide in, tide out, wind rising, sand shifting, ships passing, forecasts updating, barriers waiting, people working. The sea continues, not as a villain, not as a mystery, but as a physical place with rules that must be understood. And here you are, a little farther along your own quiet evening than when we began. We have crossed shallow banks, weather systems, tide streams, fog, wrecks, and flood defences. We have seen that the North Sea's danger is not one great secret, but many practical facts layered together. It is a sea of work, memory, warning, and movement. A sea that has given food, energy, trade, and shelter to millions, while asking for care in return. So let me ask you once more, gently, wherever you are listening from tonight. Are you near the sea or far from it? Can you hear rain against the window, or only the soft sound of the room around you? Maybe the North Sea is close to you. Maybe it is only a name on a map. Either way, for a little while you have stood beside it in thought, watching the grey water move under a wide sky. If this journey gave you a calm place to rest your mind, I'd be grateful if you liked the video, subscribed, or shared it with someone who enjoys quiet science, hidden history, and the strange details of the world we live in. It helps this little corner of calm reach other tired travellers who might also enjoy drifting through deep questions at a slow and gentle pace. The North Sea is cold, shallow, crowded, useful, beautiful and dangerous. It deserves respect, not because it is always angry, but because it is always alive with motion. And tonight, from wherever you are, you can let that motion stay far beyond your window. The tide can keep its schedule, the ships can follow their lights, the barriers can wait, the wind can move over the water. For now, there is only this quiet moment, this steady breath, and the soft thought of grey waves moving somewhere in the dark. Sleep well, fellow traveller, wherever you are listening from tonight.